Happy Friday. Happy Friday. What are you guys up to on this? Who's dinging me? We can't have dings in the chat. Can't have dings in the chat. That is unacceptable. Goodbye, dings. But yeah, anyway, so happy Friday, happy Friday. I'm pretty excited for today's stream. I'm gonna do some allocation busting. I thought that was pretty fun last stream. Had a good time just, you know, doing some things. It's like a little bit how we say samey, you know, you can make it happen without engaging too much brain. It's sort of a little mechanical. That's the word I was looking for. So I'm pretty pumped to do some performance stuff, some allocation chasing. But first, I want to show you one thing, which is this delicious soup that I'm eating. You see this soup? Wait. I made this in my Instant Pot. That didn't make it seem particularly good, but trust me, this is a delicious soup. Okay, wait. Let's try an alternate camera angle for this soup. Huh? What do you guys think about this autopilot coding? More like soup cam. Delicious chicken soup. Okay, hopefully that wasn't gross. It maybe looks gross on the camera, but let me tell you, it's a delicious soup. Are you guys Instant Pot owners? I think that my Instant Pot has changed my life, and I would highly recommend buying one if you haven't. So what happened this week? Twitter got fleets. That's pretty exciting. Big news for everybody. Now it's not just Instagram that has stories, it's also Twitter. You can post random crap to it. I think that everybody likes fleets. Everybody made fun of fleets in the very beginning, but now I feel like everybody's posting fleets every single day. So I'm not sure what to do about it. Should I post fleets of my soup? It's like kind of unclear. Yeah, I don't know. What else happened? Stuff, maybe. Tried to get a coronavirus test. The line was too long. How about that? America. No COVID tests in America. It's kind of how I feel right now. I don't know. Maybe we should just do programming. I don't have too much to talk about. So let's go ahead and do that, huh? Flip the old face cam. I'm not sure who made me set that up. I don't know how I feel about it, to be perfectly honest. Like, you flip over here. This is real me. This is flip me. It's a little sketchy, but I guess I'm okay with it. Big vaccine news, is there? I haven't really been paying attention. I guess I should be. That sounds relevant to my life and concerns. I hear one's coming, but it's gonna take time. Certainly not gonna be ready in time for Thanksgiving. That's the real conflict, right? It's like, can you have Thanksgiving with your family? Yes or no? The government says no. The people say yes. Something like that, right? So here's what we got going on. We got one, instead of flipping the camera, flip the code. That actually seems brilliant. It'll be a good sort of brain exercise for everybody. Where's my font? Good brain exercise for everybody. What's up, Death Priest? You heard correctly. This is the place for big data banks. You are absolutely 100% correct, and I'm glad that you found me, because you and I, if you like a big data bank, you're gonna fit in pretty well in this stream community. So I'm working on a patch. That's kind of the current state of the world. I'm working on a patch. That sounds like every stream, right? Basically, I think it's kind of just an evolution of last stream. So last stream, if you recall, do I still have this project thing set up? What do I have in project right now? Working on reducing some allocations in CockroachDB. That's pretty accurate. I think that's basically the name of the game. Juice Cop, what's up? Vohio. I'll never know where that little emote came from, but it's nice to see you. So last time we were doing some investigation, right? We were like running the database. Whoops. Wait a minute. Cockroach isn't a very flattering name. That's what, well, people will say that until they think about it. And then all of a sudden they'll realize that it's a perfect name. So I would like you to think about that. Think about that. What might be indicated? And what might happen if everybody complains about it a lot? Well, it'll stick in your head, right? Did you guys see the Hacker News post where people like complained a lot about the CockroachDB name last week? It was pretty funny. I think there was like 60 comments of people like debating whether or not they're offended by CockroachDB, the name. I thought that was pretty funny. I just always laugh when that happens. The moderators on Hacker News actually are used to that, and they'll like hide the comment thread because it's like for some reason people just love to fight about it. I don't know why. So what we were doing, we were running the database, we were running some workloads on it. So we were running this like 100% reads workload and sort of exploring what it does. That was sort of the name of the game. And I think we got some decent wins. I did another little set of work on this over the week, just because I find reducing allocations really satisfying. But let me actually show you. I'm gonna pull that profiler back up so we can take a look at it together. Right, so the idea with this profiler again is that it's showing you the stack and it's showing you the paths through the stack that have the most allocations. So what we were looking at last time, I think, was some stuff in the like flow setup section of the code, which is all about how we kind of instantiate the code that does SQL processing. And the particular patch that I was looking at most recently was actually something a little bit different. It was kind of about the allocations that happen inside of this thing that we call it's this whole path here, the one that actually goes to the key value layer and sends out RPCs and ultimately goes to disk to check if there's any data for the thing that we've asked for. And so specifically this thing called the dist sender is a piece of code in Cockroach that's kind of responsible for taking these requests to the key value layer and splitting them up and sending them to the replicas that they need to go to. So if you know what I mean by that, it's kind of like, you can imagine that you might ask for a bunch of data from all sorts of places in the database, in a sense. Like maybe you have a table with 1 million rows, and in a single request you're like, give me rows 1 and also give me rows 100,000 and 900,000 or something like that. You can imagine that those rows are going to be probably in different replicas, in different ranges in particular, because the table is just too big to fit in a single range. So what the dist sender does, in part, I mean, it does a lot of things, but the main functionality is that it takes that request and it splits it up by knowing where the data for a particular request lives, and it sends those requests to the nodes that are the owners of the data that was requested. So it's got to do a bunch of stuff that's like a little bit difficult. You can in fact see there's a function that sounds pretty suspiciously similar to what I was trying to describe: divide and send batch to ranges. So that's what it's kind of doing, right? It's taking a batch, finding where each of the subparts of the batch need to go, and sending them out over the network, as the case may be, or locally. So that's another option, right? It's like if it so happens that you've asked for data from the node that, if you've asked for data from a range that is owned by the gateway node that the SQL request is being served on, then this send to replicas thing is sort of like a no-op. It doesn't have to send out over the network. It ends up just talking to the local node. There's a fast path for that. And I think that does happen here because, well, the test case that we're doing is just a single node database. So of course it's always going to hit that local path. The point is, what we were actually looking at, let me actually get that up because I feel like whatever windows I'm in right now are sort of random. What we were, wait a minute. I guess I was doing a couple things at once. Let's go ahead and stash this. This was another experiment that I didn't really finish to avoid some allocations, but actually, why don't we pull up the PR that I made? Because I got some responses to it that I want to look at. I think that would be good. Author me. So this commit adds an object pool for gRPC transport, an object that was created on every call to disk sender along with a slice of replica descriptors and a map of healths, right? So the idea here was that every time we ask for information from that disk sender, we end up creating a new object that's called the gRPC transport. That's, well, it's sort of a gRPC network sender object machine thing. And so that was showing up pretty heavily in the allocations profile. And it seems like kind of pointless. It seems like one of those objects that's really easy to pool. So I sort of thought we would do it. Hey, Patapip, what is up? Does database optimize for maximum? I don't know what word that is. For maximum utilization, I've seen, cache line, I see. I've seen Scott Myers talking, he mentions common use case of cache optimization for web is database optimizations. Is that true? So that's a pretty good question. I think depending on, there's lots of different layers of the database that each do different things for trying to optimize their cache usage. And I guess I'll speak to the one inside of SQL execution because that's the one that I know the best. I think like there's two big parts of the database that end up having to use to like look through a ton of memory. One is like the storage layer, the part of the database that actually gets big chunks of data from disk and has to organize them, you know, in memory and search through them. And I don't understand enough about the storage engine to really talk about that. I would assume that people have thought about how to optimize that part of the database for cache utilization, but I don't really know. In SQL execution, we did spend a lot of time recently re-architecting the way that we store SQL rows and datums in memory such that we do avoid having to follow too many pointers, essentially. It's really like, how can we organize our SQL data such that the operators that work on that SQL data are always looking at just a single contiguous chunk of memory. And that's what we in Cockroach call the vectorized execution engine. It's really about storing columns of data contiguously so that operators don't have to follow any pointers to do their work, ideally. There's still some cases where they have to follow pointers, like for certain types of data, like decimal objects or UUIDs. No, I think UUIDs are stored contiguously now too. There's like a few things that we haven't like optimized for this yet. But for all of the like common simple scalar data types, including strings and bytes, we store them in a contiguous way so the operators don't have to follow any pointers to do their work. So I'm not sure if that answered your question. I think like that's kind of a hard question to answer completely because the database just does so many different things with data. Anyway. So pointers most of the time are bad because of indirect memory reading. I mean, I wouldn't say that. In general, like kind of, right? It's like, yeah. Pointers by themselves aren't bad. It's like pointers to distant data are usually the things that would get you to thrash your cache, right? Data that isn't in your, you know, processor cache or whatever it is. It's going to take a long time to retrieve it from RAM. So like pointers themselves aren't bad, but ideally you would just be thinking about reading like a single page of data at a time, or at best, you know, if it's not exactly that, then at least it's contiguous data. So you have to, you know, change out what's in your cache as infrequently as possible. Yeah. I don't know. I don't know. Yeah, what would he say about it? I'm sure he knows. Sure, he would have all sorts of stuff to say about it. I wish I actually spent more time in my professional life doing C++. I've never really done it. So I don't know too much about C++, honestly. So right, back to this project. We wanted to, I mean, it's sort of similar, right? Let me show you what I'm even talking about. gRPC transport. So we have this, piece of code that gets a factory for gRPC transports, and it sets it on this big singleton guy called the dist sender. And this transport factory is the thing that I was kind of messing with. So let's take a look at what happens when we call this transport factory from the dist sender. So again, this is the part of the code that gets invoked when Cockroach needs to send gRPC requests for key value data to anywhere. So this is like a super, super hot path. This code gets called like on every single database request multiple times, potentially. Like it's either at least one or possibly many, many times. So what we have to do is that every time we have to initialize a new transport. And I guess I was sort of wondering, like, why are we doing that exactly? And in particular, I was wondering not just idly, but because it was showing up pretty heavily in this, like, you know, pprof graph of all the allocations. I think in this one, it's not going to be here because I was profiling after I made this object pooling change. But in any case, that's kind of why I was doing it. It wasn't really completely out of the blue. Get your factory functions out of my Go code. Oh my God, you guys are like anti-factory zealots. That's like really disturbing. I didn't know that was a thing. What do you call a function that has to make another thing though, if not a factory? I feel like probably a lot of Go programs have those. They maybe just call them something else, like transport maker. But the point is, like, why did we have to keep creating these objects when, you know, it just seems a little bit unnecessary. So I thought that maybe we could add a object pool for it. Just judging based on the name. How about singletons? Okay, you can tell that I'm an ex-Java programmer, I guess. I'm using too many pattern words for everybody's taste. Very disturbing. So the new thing that we do, instead of making, let me show you what the implementation of this thing looks like. So gRPC transport factory impl. You were just joking. Okay, great. Thank goodness. When we invoke this factory, it used to say something like, you know, transport is equal to, you know, just instantiate a fresh gRPC transport like so. And I changed it to use this pool. And in particular, like one big reason why I wanted to change it to use a pool is that inside of this object, there's a slice of replica descriptors. And this allocation of this slice was also showing up pretty heavily in the profile. And I think that usually a pretty good sign that you could be using object pooling to great effect is if you have an object that's getting allocated over and over, and inside of the object, you also have some other objects that are getting allocated over and over. It's sort of a hint that, like, wait a minute, maybe I should be allocating this tree of objects all at once and saving them and reusing them over time. It's not normally necessarily the case that you should do something about this, but like if it so happens that it's bad in your profile and you think that it's important to optimize it, it could be a hint that this could be a place to look. I didn't write this code. I didn't write this code. I think it's an impl. It's an impl. What can I say? We have one for the race detector build and one for the non-race detector build. Why? I couldn't tell you. I couldn't tell you. I could get blame. I could get blame, but so could you. Do you think it's a bad idea to have a special implementation during the race detector build? So I'll tell you the reason we do that. The reason we do that is that we like run the race detector builds on, we run all of our tests under race all the time. So we run two sets of tests, you know, one non under race and one under race. And I think what happened here is that we wanted to overload the race detector test meaning to do a bunch of other stuff, is my guess. which I think we've done in a few different places just because we have some like slow paths essentially. I don't know, that we want to, what does it say? gRPC transport factory during race builds wraps the implementation and intercepts all batch requests, reading them asynchronously in a tight loop. This allows the race detector to catch any mutations of a batch passed to the transport. The dealio is that the batches passed to the transport are immutable. The server is not allowed to mutate anything, and this transport makes sure they don't. Oh, but like, look, somebody also says we don't like this transport very much. So I don't know, dude. I truly don't know. It's slow, preventing us from running clusters with race binaries. And the way it's written, it prevents both the client and the server from mutating the batch request. So it sounds like nobody likes this. Okay, so what did I actually end up doing is that I get this object from the pool, I grab the saved slice memory from the transport, and then I either make it longer if I need to or slice it if I don't. And then similar, I think a couple streams ago or maybe last stream, we were looking at using these fast int maps to avoid having to allocate maps. So I used one of those here. We used to have sort of just like a, let's make a map and then do some stuff with it and then throw it away, which is always kind of an anti-pattern. Especially because apparently the number of things in this map. So what's this map about? It's really about trying to take all of the replicas that we're going to be sending data to and checking if they're healthy and prioritizing the healthy ones, I think. So, I mean, one thing I'll say is that this code, it's definitely not code that I'm super familiar with. So I'm learning about it as I'm messing with it, just as you guys are. So if I'm saying stuff that's imprecise, it's because I don't even know what it's doing. So, but look what it says. Put known healthy clients first while otherwise respecting the existing order of the replicas. And so inside of this, we do a sort and we have this little like, you know, sort machine that checks the health of the replica as a sorting criteria. That's what's going on down here. But in any case, we were using a map before, and I asked the people who know about this code, and they said that the number of replicas here is always really small, like probably less than 10. And as it so happens, we have this really nice abstraction for maps that are size small. So I decided to use it here. And I think that was uncontroversial. I think the controversial thing, oh yeah, so let's take a look at the code review that I got. So it turns out that somebody, Andre, made this change in this PR that ended up accidentally adding an extra slice allocation that I was looking at. So I was sort of wondering like, what's the deal? So I tried to be courteous. I said, Andre, I'm sort of partially reverting something. So I just want to check with you if it makes sense. So I think he responded why he doesn't want. So essentially what I changed is that it used to be that when we invoke this thing, this transport factory that everybody's making fun of because it's a factory, when we invoke it, what we do is we pass in a set of replicas, and the kind of replicas that we, wait a minute, is this, yeah, the kind of replicas that we're passing in, like this argument type, it's this thing called a replica slice. And interestingly, a replica slice is actually not a slice of replica descriptors, which is sort of the underlying type of replica. It's actually a slice of something that contains replica descriptor, which also includes something called a node descriptor. And I think the point of this patch that Andre made was to remove the node descriptor from the arguments to the gRPC transport. And the reason for that is that it just doesn't make sense. Like the gRPC transport doesn't need to care about these node descriptors, and he thought that it was confusing, so he removed it, which I think is like a reasonable reason not to include it. It just introduces some performance issues because you can't like pass a slice of structs, but only include the inner part of the struct or something. You have to make a new slice for that. So that's kind of like what we are messing with. Yo, Yoda Droid, what is up? Hello, hello. Yourself. So I guess what I ended up doing is, yeah. So what happened before was that when we actually called this transport factory, instead of calling it just with replicas, we were calling it with, now I thought that this guy had a method called replicas that pulled out this, oh, descriptors, there we go. Okay, so, right, it sort of looked like this before, replicas.descriptors. And this transport factory thing took, instead of taking a replica slice, it actually took a replica descriptor slice like this. And I think that there was the objection is just like, we don't want to pass in all of the replica slice. So I don't know. I guess the question is, should we, this is the suggestion, right? We change replica slice to have 2 independent slices. There's some suggestions about allocators or something. So I guess we'll have to take these suggestions. This isn't, yeah. I think this is a reasonable suggestion to try to change replica slice to have 2 slices inside, I guess. So I guess we'll do that. So let's try it out. I guess, like, first of all, what we should probably do is, let's get rid of this. I kind of need to clear out my untracked files. I feel like this is driving me crazy. So I can't even see my Git status because of all the untracked files. Is there like a solution to this? I don't know. I don't even know what all this crap is, but it doesn't seem that important. It's just like random stuff that I did a long time ago, I feel like. Org to OPML, I remember. Oh man, who uses org mode? Anybody a big org mode fanatic? Emacs users are wild. Yeah, I'm not really an Emacs user, but I tried using Spacemacs for org mode for a while. It was pretty good. I mean, I like org mode quite a bit, but I sort of like forgot how it worked over time, and then I haven't really returned to it. Is there an org mode for Vim? There is, but it's not very good. Is Go a good beginner's programming language? I think it is, Kappa votes. I think it is. Yo, Wacolder Bear, what is up? Nice to see you. Get rid of this, get rid of this. Okay, this is looking a little bit more sane. You've never opened Emacs, and when I got my Kinesis, I lost the ability to use Vim. Oh no, that is really bad. Okay, so what I usually like to do when I'm gonna completely change a patch, I don't know if you guys do this, but I like to just reset to the previous so that I can see all of the changes like in my, as like dirty changes. I get, it kind of gets rid of like the whole commit message, which is a little bit annoying, but then I just reconstruct it from my git ref log or from the pull request or whatever. Emacs is good for playing Tetris. Okay, so now that I've reset this stuff, I should be able to see the diffs in my IDE, which I find is like kind of helpful for remembering like what I've changed in this patch and what I haven't. So ultimately, I think what I need to do is like reset all of these changes from replica slice to replica descriptor. Any chance of seeing MD Layer stream again? MD Layer, big friend of the stream, so I also hope that MD Layer returns to streaming soon. Safe to type. I'm vimming on my Kinesis as we speak. Not an issue. Think it feels more ergonomic. Yeah, that makes sense. I don't think that changing to Kinesis should necessarily change your Vim. I think the big problem would be changing to Dvorak or whatever. I hear people complaining about that a lot. It's like, I changed to Dvorak and I don't remember anything about how Vim works. I feel like that's a pretty common complaint, which seems pretty reasonable as complaints go, to be honest. What happened to my alerts? Did my alerts die here? Just want to make sure that King Ollie gets his alert.
The data bank's too big. I have to narrow
King
down
Ollie,
the search.
thank you for the follow.
How are you going to do that? By guessing.
Okay, so we're gonna just like kind of wipe out some changes with git co-p. I think I taught some of you guys about git add-p last time. Git add-p is a way of adding hunks to your staging area instead of just full files all at the same time. But it turns out that you can use -p with a lot of git commands, including checkout. So with checkout, if you do git checkout-p, it's gonna just get rid of any changes from your working copy, hunk by hunk, which is kind of what I want to do right now. So we'll try it out. We want to revert this guy. Essentially, we're reverting the changes that changed the input types to transport factory from replica descriptor slice to replica slice. So we are going to revert this one to revert this one. We're going to keep this one. Keep this one, revert this one. Keep, revert. Keep, revert. This is probably like incomprehensible, but I'm having fun. Revert, keep. Okay. Abused -p so much when I first learned about it. Now I just try to make smaller commits and do fix-up squashes. Yeah, I think that makes sense, Stack. I think most of the time I try to do that too. Just feel like some of the time it does come in handy, especially when you're trying to mess with a commit. I mean, honestly, sometimes it happens. You want to revert part of it. It's just hard to keep everything super atomic, especially during a code review. I feel like it's all really about the code review workflow, right? Oh, Control L to clear terminal. Yeah, that's like a killer. That's an absolute killer. I feel like I use Command K to do that a lot because it also clears my iTerm scroll back, which is pretty useful because then you don't have to, if you want to clear your like search buffer, like do a giant command and then search through it, you kind of want to Command K first to get rid of that scroll back, or else you'll get confused about whether the search results are from the current search, the current command or the last command. Okay, so now that we've reset this thing, now we've sort of got to figure out what is going to happen next. So this is just going to be R. I think ultimately this is, okay, so check this out. This is sort of one of the big sources of these allocations that I was trying to get rid of, which is that inside of the gRPC transport implementation, we're taking this replica slice and we are copying it into a pre-existing replica slice. But the replica slice that we're passing into this transport factory, it itself merely makes a new slice of replica descriptors and gives it back. So it's sort of just like throwaway memory. And that's just the sort of thing that we don't like. If you can possibly help it, when something is such in the hot path, which this is, since we do call this, at least once per every single SQL query that somebody sends at us, it's ideal to not have any sort of pointless allocations like this. So the suggestion that Andre made in the code review that I think I'll try to take is to make replica slice into a struct that contains two slices instead of a slice of structs. So it's sort of like the array of structs versus array, or structs of array pattern that sometimes comes up. So let's try it out. So instead of having type replica slice being a slice of replica info, we're going to have type replica slice being a struct that has a slice of replica descriptors. Guess we can comment this out. And then a slice of, or I guess it's sort of replicas and nodes, roach pb.node descriptor. And then I guess the question is just, how do we fix like all of these different problems? I guess it's probably like we want to just pick one of them to be sort of the main slice to look at. And for here, we've got to do we've got to do this swap twice. I mean, is this really right? I don't know. I also use Homebrew. I think I used to use Mac ports. Then I switched to Homebrew a long time ago. But I don't know. Homebrew these days, like, is it the best thing ever? I would say no. I would say it's like fine and it has issues. Imagine a language with a meta layer capability to mutate between struct of array, array of struct, and array of struct of array at compile time. That would be pretty epic. Is that a thing that exists? An animal? I don't even know what that exactly would mean. I guess it would sort of... C++? Can C++ do that? You can do that with templates without a lot of work. Yeah. That would be pretty cool. Move to front moves the replica at the given index to the front of the slice, keeping the order of the remaining elements stable. This function will panic, blah, blah, blah. Okay, so we'll just pick replicas. And then I guess we have to do this operation. Do we actually use this move to front thing? Guess we do, huh? So we'll have to do it both times. We grab the front replica, front node. Okay. Sort replicas by latency and then attribute affinity. My goodness. My goodness. What is this dot adder? Node des.address.string. These are just sort of like convenience methods on top of the thing that was previously known as replica info, which we're no longer using, right? This thing is now sort of dead. So adder. I feel like this adder thing doesn't really give us that much. So why don't we actually just change it to say this is going to be a method on the replica slice, and it's actually going to take an index. How about this instead? And we'll do the same thing to locality. Whoops. How much would you say you use techniques like test-driven development? I would say basically never, unless I'm doing something like new. I think And TDD, I would say never. I would say never. I think that there's a lot of testing techniques that I like to use, but TDD isn't really one of them. I think my favorite testing technique these days would have to be metamorphic testing, which is kind of a more advanced kind of, well, I wouldn't say advanced. It's sort of like a different kind of property-based or randomized test in which you have a big test corpus that you've built over time. It could be random, it could be static. And then you have some properties that you are asserting about something about the function over your test cases. Like, for example, maybe a metamorphic property could be that no matter, like if you're operating over, maybe you're testing a join or something like that. The metamorphic property would be that no matter what kind of join, you always get, multiply the left by the right or something like that, that number of things out. That's not exactly right, but something like that. You sort of pick this meta property about your test cases and assert that it always holds no matter the test case. I feel like we use that a lot in the database to great effect. Okay. I think, yeah, metamorphic test. Somebody to read is Hillel Wayne. If you follow Hillel Wayne on Twitter, he writes a lot about property-based testing and metamorphic testing, and it's pretty interesting. I would recommend following him. Nowadays, I just do explorative programming and diverge between code paths when necessary and see which one ends up being better for my use case. Okay, so we've got our new locality methods. And then for here, for descriptors, we can literally just return rs.descriptors, or replicas rather. Okay, so then this is just about creating one, right? So for here, we've got to say rs, we'll say var rs. Well, maybe we'll say rs is equal to replica slice. And then we'll say descriptors, wait, replicas, make replica descriptor 0 when voters. Okay, and then down here, I guess we'll say append rs.nodes, nd, and then append rs.replicas r. What's the matter here? It's the wrong type, huh? So we're getting these as pointers. Should we keep them as pointers? What does this do? This returns a pointer. And they're stored as pointers in some slice. I think we should keep them as pointers then, since this isn't going to allocate any more than it already has. So this is going to be a slice of pointers to node descriptor. That's the feeling I've gotten after being too strict. Some good ideas can be useful in some situations, but you can't use it blindly. Yeah, absolutely. I agree. I agree with that. This is a slice. We'll say a replica slice is a slice of replica descriptors with an associated slice of node descriptors. Each node descriptor corresponds to the replica descriptor at the same index. Slice of pointer to slice of pointer to foo. Okay, so here we will say okay. Okay. So now what? Now I think the idea is that we've got to, I think we're probably good now. So we're getting our slice of descript. I think we should probably change this method to say that you shouldn't mutate the slice or something, because I think that's true. This slice shouldn't be mutated. This is classic Go. You return a slice, and then instead of being able to say that it's const or anything, you have to be like, please, do not mutate me, which is a little sad. I guess we could make like a thing that has methods that you could get or something, but we're not going to do that. We'll just have to hope, because we know all the users, right? It's all good. Okay. You know, it's actually kind of funny though. You know, it's actually kind of funny though. We actually use, this is the very same method that we were just editing, right? More than often than not, you gain experience, identify little techniques that help a bunch, yeah. Hey, Kina42, welcome, how are you? I think what's kind of funny about this situation is that I don't think that we actually keep this replica slice around. I think we throw it right away. I think we throw it right away. We really do throw it right away. And because of this, I feel like we actually can I don't know. I feel like there's some higher level object that we really should be pooling. We shouldn't be pooling just this transport. We should really be pooling like, it's like a dist sender sending instance in a sense. Like there's all of these scratch variables that you really want to be reinstantiating and then throwing away, then reinstantiating and throwing away. And we really ideally would be able to cache all of that memory all at once, because it would really save a lot of effort. I just don't exactly know the right abstraction, and I may not be able to figure it out here because I just don't know, and it's a bit complicated. This whole structure is pretty complicated, but the truth is that well, I guess we do use this in a couple of other places, huh? What's happening here? Did I not revert this one by accident? What happened here? What happened here? Oh, I see. What happened is that I need to go like this, I guess. I see that replica slice is used by a couple of different other places. It's like a little sad. It's not used by too many other places though, so I suppose we ought to just change this one. What is this one doing? What is this one doing? The oracle. What is the oracle? Oracle is used to choose the leaseholder for ranges. This interface was extracted so we can experiment with different choosing policies. Note that choices that start out random can act as self-fulfilling prophecies. If there's no active lease, the node that will be asked to execute part of the query will acquire a new lease. This seems like really important code, huh? So in Cockroach, right, we have a bunch of replicas for every range, and a range is a chunk of data. and the leaseholder of a range is the replica that can serve reads. It's very important. And so I have never really looked at this code, but it seems pretty interesting. Wrong kind of oracle there, Wacholder Bear, but I think that's pretty funny. So choose, oh, this is a random oracle. So we have a few different oracle implementations. There's a random one, and then there's a closest one, and then there's a bin packing one, and they all have to query these replica slices. I don't like that replica slice is used in both places. It's so confusing. Oh, it's so confusing and bad. We should really have two different types because I feel like this whole dist sender stuff needs to have its own special optimized. I mean, this dist sender thing is much more highly used in a sense, and it's much more of a hot path than this oracle. So it feels to me like it should have some optimized stuff in there, whereas the oracle, we don't really care. So in conclusion, we should probably figure out what we actually do in center replicas with these node descriptors. Hey, thanks for the follow, Benz 1000 and SNWLOL. Did you guys subject your database to controlled nuclear devastation already? Not nuclear, but we did do this pretty funny demo, which I would really like to. I don't think anybody captured it on film, but we hooked up a CockroachDB cluster to, well, we ran one on a bunch of Raspberry Pis that were networked together, and like hooked them up to some interface where you could see the like the admin UI and stuff of the database. And then we actually had somebody smash one of the Raspberry Pis with a hammer to show that the database could survive one of the nodes going down, but in a very dramatic fashion, known as smashing one of the computers. That was pretty hilarious. Yeah, great marketing, right? We definitely should have done that on video. I think it was like a demo at a school or something, a university recruiting thing. I can't exactly remember. Cockroaches survived on Raspberry Pis. Okay. Oh, you know what's kind of interesting is I think that all of these things in the oracles don't actually care about the node IDs. Is that right? Is that right? Can we just pass in the descriptor slice itself instead of messing with this whole replica slice abstraction? I think we can. What is the, I don't understand the point of this, to be honest. Replica slicer error. Oh, do we sometimes call the optimize ordering thing though? That would explain it, right? Replica slicer error. Yeah, then we run optimize replica order. Okay, so I think really we just need to say like descriptorsify it and then go like this. And we can do that everywhere and then we should be good to go. Maybe we can capture this variable. Okay. And here we take a random one. Isn't that fun? Why don't we just capture this again? All right. I think that's good. I think that is fine. Okay, so why don't we go ahead and recreate this commit. So here's a question, right? It's like what I really want to do is I want to show git show head at 2. And I want to like take this commit message and use it on my new commit. Does anybody know a way to do that? That's really what I want to be able to do here. Because the classic problem is that this commit message now has all of these extra spaces, so I can't perfectly copy and paste it. I mean, I can just edit it in my editor, which is what I will do, but I just find it a little bit irritating. I really want to be able to, like, yeah, take a commit that already existed, but just its message. I am using IDVM, yes. Okay, so let's go ahead and push this up. And back in our remote benchmark machine, we can fetch. I guess it's fetch mine actually. And we can reset to my new branch here. We can build. We can take a bite of our soup. Nope. I probably should have tried to build it locally first, huh? Just sender range feed. I probably just didn't finish making this change completely. Just sender range feed. Okay, so what happened here? The answer is that I've got to just go like that, I think. Oh yeah, wait. What did I learn last comment? Somebody gave me this really good Git alias last time. It was called Git. It's a git commit amend no message, right? Commit amend no message. Git cane. Git cane. I love that so much. Oh man, that's so good. Okay, we'll push this up. I'm all about the git cane. Okay.
Data back,
so we're gonna fetch. We're going to reset. Then we're going to rebuild. Okay, while this is building, I'm gonna get a brownie. BRB. ISO brownie? Okay, I'm gonna show you guys this brownie. Delicious brownie. This was recently lovingly baked by my girlfriend, who loves to bake as a stress-reducing activity. You know what's really stressful though is Thanksgiving plans. That's why everybody's stressed right now in the large data bank household. How do we see our family? Do we see our family? Do we not see our family? Can we get COVID tests? It's stressful. So, well, bottoms up to the brownie. It's pretty delicious. Thank you, Becca. Dip it in the soup. That doesn't seem particularly well advised, to be honest. Okay, so let us go ahead and run this. Whoops. Okay, what did we do wrong? Call of swapper on 0 value? Now that I've never heard of in my entire life. It is funny though. It is certainly funny. Pumpkin soup, interesting. It's actually got some pumpkin in the brownie itself. So you read my mind, maybe by looking at the picture of the brownie. So what is this? Replica slice 194. Called on the 0 value? The heck? So I guess it means that, wait, what? Call of swapper on 0 value. I guess it just means that if this thing is empty, then it can't work or something. That's kind of random. The soup is, it's a white bean, chicken, rutabaga, potato, other root vegetable, onion soup that we made out of a bunch of leftover root vegetables. Yo, bro, Hanster, what is up, my man? How are you doing? I don't get this exactly. Paper deadline today. Okay, so perfect thing to do is to join the stream and hang out. It's a good thing to do during a paper deadline. I know what you mean. I know how you feel about that. Brownies from Halloween leftovers. I still don't exactly. I'm guessing that this is just an empty struct or something, but I don't really understand why that would be a problem, right? Swapper.go 19, huh? If, oh, you can't call this on a slice, dude. Okay, right. You can't call this on a slice. That actually makes a ton of sense. Is Justin here? I don't think Justin is here. But you should send this to him. Think you're incapable of doing schoolwork at this point? I can't fathom having homework, papers, or studying for exams. I exactly agree with you. 1000% agree. Yo, Hertox, what is up? Okay, so how do we do this, huh? We need to do a, oh, you know what we should do is instead of doing sort.slice, I guess what we have to do is have replica slice implement the sort thing or whatever, right? That's the way to do this. There's sort dot. No, I thought sort dot. Sort. It's just sort.sort. Okay, so we need to do sort.sort on RS, and then RS has to implement some stuff, so we can do that. Okay, that's gonna be easier anyway. A little bit less messy. So we'll put this over here. We'll grab this stuff here. Oh my God, but it has to be a closure. What a disaster. What an absolute disaster. Oh, you know, well, oh yeah, this is bad. This is not good. I guess we have to, set these things on the replica slice itself and then pass it around. Oh, it's really not good. And this is not gonna work either, is it? Oh boy. Truly bad. Truly, truly bad. Well, so this is gonna work. The shuffle will work, but the sort will not. Okay, so we're just gonna. Ugh, it's gross, man. It's gross, and also the fact that we set this as an object.
Computer's hooked into over 1,000
is
data
problematic, I think. Hey, thanks, Pressures Up, for the follow. And also thanks, Pravind Inwa, for the follow from a while ago.
The computer's hooked into over 1,000
Iverson
data banks
Forever.
throughout the world.
Iverson Forever. I like that username. I guess, well, let's just see what happens. These fields. Well, okay. What about we make a new type for this or something like that? What if we make a new type? What if we make a new type or something? Ugh, it definitely feels gross. It definitely feels gross. What is the sort interface? You need a swap for that too, right? Yeah, len less and swap, right? I think we're gonna just try to add a member onto this thing and see if that like breaks everything. I'm not sure if it'll work. So we'll say these fields are for sorting the replica slice by by what? Optimize? The replica slice period. I guess we'll say these scratch fields. And we can make embedded struct maybe, just to make it clear. And we'll say it's got a local node descriptor, whoops. And we've got there's some func, right? The func is what? It's a latency fun, and it is literally a latency func. Okay. Oh, and this is a pointer, huh? Okay, I don't know, dude. This feels nasty, to be honest, but like, we'll just try it out. We'll just try it out. It shouldn't be too big of a deal. So we're gonna say replica slice dot scratch dot latency fun is equal to latency fun dot local node is equal to node desk. What's up, Boratsky? Idea Vim RC, I don't think I have anything special in there, but let me check for you. I literally, Boratsky, all I have in this file is this. I don't even know what this is. I think it's just to like make it, I don't even know. I don't have anything in my Idea Vim RC. I did tweak a bunch of stuff, but I guess I did it in the IDE, which isn't really that helpful. You once mistyped Broadridge as Borat Ridge. Are the allocations from this function a big impact? So Brohanster, I'm on a crusade, which is known as it's known as everything in the read path of this stupid database. So many little things. They'll all have like, oh, send to replicas is 1.2% of the total allocations. And you'll go over here, it's like, oh man, 0.5% of the total allocations. And you'll go down, it's like, oh, 0.46. And like, nobody has a lot of allocations, but together, everybody has a huge number of allocations, and they all add up. And so my dream would be that if we spend some time slowly, carefully chipping away at these allocations in like, they're sort of pointless, but nobody's cleaned them up because they're just small, right? But I think that together there's a lot of pointless allocations that add up to be a lot. It's just like, it's hard to see it. So my dream is to reduce them by a lot. We'll see how it goes. Your last name is Borak. Very cool, Borak. What country are you from? Or like, what country is the name from? Somebody actually sent me a link to something that was pretty motivational that I'm gonna share with you guys related to this allocations problem. It's called The Story of SQLite Reducing CPU Cycles for a Workload by 50% with many small, less than 1% improvements over the course of a long time. Have you thought about any ways to stop this crusade from getting slowly undone after you're done? No, I have not thought of any ways to do that. But if you have any ideas, I would be all ears. I think the truth is that we just have to rely on benchmarks, which certain benchmarks we do track their behavior over time. And I think people do notice when some of these benchmarks, like special ones, like they start to tick up in badness. So we have to sort of, bless some special benchmarks as important, and we can watch their behavior over time. And hopefully we can have one that kind of cares about this particular thing, which, yeah. Borak is one of the mispronunciations of Borat in the first movie. Dominique, how are you doing? More crusades are required normally. Yeah, I think you're right. Maybe the crusade is never over. Okay. So I think that at this point, we should probably have fixed this issue with the brokenness. So let's see how that goes. My apologies. Dominic. Okay, Dominic. Where's the what do you call it? Emphasis. Which syllable? On the first one then. Okay, very cool. Okay. So we'll do our fetch, we'll do our reset, we'll do our make. The H seems to trip people up. It's, yeah. Okay, so let us rerun this thing. Maybe we won't crash this time instantly. Great. Normally super judge people who use their first name only as a username, but you get away with it by adding one letter. You would detest being Matt anywhere, too many accidental pings. I think that would be cool though. Isn't that the dream? Everybody wants to have the, what are they called? There's OG names, right? There's like, I feel like there's some reply all episodes about OG names on various services that I've enjoyed quite a bit. Bouncy, tell you have my get status aliased. Yes, I do. Smat could be Rob everywhere. Hey emails, yeah, I never signed up for Hey. I don't know why. That was confusing to me. Okay, so let's grab a new heap profile. That website, that thing, like the hype seems to have completely died, right? Okay, wait. I can't tell. Do you think Andre and Nathan are watching my stream right now? Andre says, I guess passing the replica slice into the transport factory is not the worst thing in the world. But I just spent all this time on doing it. Oh my God. Truly not great. The first commit, LGTM. I'm not so sure about the second commit, actually the rebase commit. Andre and I spent some time talking about it today. From my perspective, it's not worth the added complexity or cost. What do I think? Well, I don't think I really care. That's the truth. I just want to get rid of the allocations. So I will... Here's another desperate thing you can try. If you slap an inline always on replica slice.descriptors, does the backing array for the slice it creates still escape? I don't know. Dang. Why don't you guys come talk to me about this patch? We are working on it right now. truly the dream to have a 40-person strong code review team. We'll see what they say to this. All right. Okay, so why don't we go ahead and look at our object allocations and see what we imagine having to work with this guy. I hope you're talking about me. Okay, so send to replicas is what we've been messing with, right? Sure has much spare space for data reserved between the words. You're talking about my underscores? I'll never get rid of my underscores. So, I guess I just don't know. I guess I did kind of like it the way I had it before this big suggestion happened. But the truth is that I don't know. Because the truth is that what we really should be doing, I feel like, is pooling this replica slice object inside of the transport or something like that, because then we could avoid having to create any of these slices altogether, which would really be truly the dream. You thought your name was an unfinished game of Hangman? Like, what about this as a concept? What about this as a concept? This would be known as the concept of when we call send to replicas, instead of asking for a new replica slice, what we actually do is first get our transport. Like, it's essentially like we stop passing in our descriptor list inside of, like, to this transport factory thing. And instead, the transport factory that's given back to us has a method of, like, copying the descriptors in. And the purpose of this would be to essentially, like, we would sort of inline this new replica slice thing into the factory method or something like that. Oh, I don't know. Maybe it's just too complicated and I should give up. Because I think that all this code is, it's the other thing is that it is used in other places, right? Like, the whole point was that this Oracle thing also uses the replica slice. Oh, I don't know. Largest data to bank.
The computer's hooked into over 1,000 data banks throughout the world.
I think that I agree. The first, that just passing in the replica slice is the simplest thing to do, though. It doesn't particularly Andre, the man himself shows up. Make a replica slice dot descriptors take in an array and populate it. Yeah, totally. I think I don't think that would actually save us any allocations, because we're still having to allocate in this new replica slice thing. I think it's either like we just pass in the whole replica slice. I mean, I guess they're all sort of equivalent, and maybe it just doesn't matter too much. Maybe we're just sort of maybe it just doesn't really matter too much. I think the only like really next level idea would be to try to cache this replica slice thing inside of the factory. And I just don't know if I want to go through the effort right now. Out of curiosity, like, where that presumably does show up in this chart, right? Presumably that does show up somewhere. New replica slice. Okay, yeah. So we end up, why don't we see if we can see that over here? What is up, the Swiss, and hey Lithium, nice to see you. I had kind of thought or dreamt of contributing to CockroachDB project. The project seems so cool to me. I am kind of normal programmer and a bit scared. Are there any low-hanging fruits or so for new contributors? I will say that everybody who works on CockroachDB is in a sense a normal programmer, so you should not feel scared. And there are plenty of low-hanging fruits. So what I would tell you about low-hanging fruits is go to the issue list here and search for good first issues. And this is going to have a big list of issues that we consider relatively straightforward for people who are new to contributing to Cockroach. So I would definitely recommend checking out this link. But thanks for your interest. Oh, you're very welcome. I hope to see you sending PRs very soon. The truth is that we don't actually see, I'm a little bit surprised. So what if I focus on this, right? What if I say view, what if I say focus on send to replicas? Shouldn't I in fact see, okay, so new replica slice does show up. But it's, I guess it's like, like the true dream, right? We don't have to be allocating here and we don't have to be allocating here. Both of these things are sort of, in a sense, unnecessary because we could pool them all up into the gRPC transport. That's all that I'm trying to say. Why do we have to allocate inside of optimized replica order out of curiosity? Is that this shuffle.shuffle thing? It's the sort.sort. And it's because we're conv T2Iing. Man, this stuff drives me crazy. I have to say that it drives me crazy to see all of these conv T2Is happening. I don't think that it's just, I think it's just like the way that Go is designed. Unless you pass, I guess if you pass this thing as an interface, is that how it works? Or a pointer, we wouldn't have to allocate there. But then again, we're just like re-changing like the way that we're storing all this data again. You know, that being said though, I do think that if we did this suggestion that I had, where we pool the replica slice inside of the gRPC transport, then we wouldn't have to allocate either here or above. So maybe this is actually the dream. Maybe this is actually the dream. Yes, Lithium, this whole view is showing allocations. It's an allocations profile that we took using Go tool pprof. So what would happen? What would happen if I said that this transport factory is going to give me back something that lets me set the replicas, right?
The data bank's too big. I have to narrow down the search.
How are you going to do that?
Hey, thank you for the follow,
By guessing.
Mohammed. Much room for dope optimization. Okay, so I think here's what we're gonna do. The first thing that we're gonna do is we're gonna save this particular version in a branch. So this is called, we'll get checkout -b. We'll call this kv transport struct of arrays, and then we're gonna reset back to our original copy because it sounds like people don't necessarily care about it sounds like people are okay with the first commit. So I'm gonna reset back to that one. So I think where we were was Actually, I don't remember. I wonder if I can find out the name of the original commit here. Is it 21F1 or whatever? This one, right? So we're gonna get checkout KV transport, and then we're gonna reset to this guy. Okay, so let's see. I agree that the replica slice and the gRPC transport should be merged, but I'm not sure what the best way to do that is. The problem is that this sender code is not structured properly. We have 3 layers that all have some control over where the next RPC should be made. These should all be collapsed. That I would believe. I would certainly believe that. I don't know how to solve that problem. I do think that I can see a way to merge the replica slice and the gRPC transport though. I think I'm gonna try to do that next and we'll see how it works. Yo, Nikon, how's it going? Welcome back. Okay, so we've reset to our original patch. And I think what I sort of want to look at is like, what if, wait, why does this have just a replica slice? Now I'm confused. This is where we create the new replica slice. This is where we do some stuff. This is where we pass it into the factory. And then what do we do inside of this factory? Ah, right, it's that we have the embedded slice of replica descriptors. Okay, so here's what I'm thinking then. Here's what I'm thinking. Basically, instead of storing this replica slice as it is, we'll actually store a real replica slice. So we'll call it replicas. We'll just call it replicas 2 for now. Replica slice. And then when we actually make this thing, so we'll fix release and everything later. I mean, but the fundamental idea, right, is that instead of doing, we'll also be reusing our replicas slice memory, gt.replicas2, and then the idea is going to be that instead of populating this in the constructor, since we can't really, we will instantiate it afterwards, right? So this impl is going to start not taking a replica slice, and we need to make a new method. I mean, the new method needs to be called like func gt grpc transport, and it's like populate replica slice or something. And this is going to take whatever the arguments to the new replica slice thing is. New replica slice. So context, node desks, desk, leaseholder. I think we can just probably copy all this stuff. I don't know. I mean, this might not work out. I'm just gonna play with it and see what it gets me. How about? And then I think what we want to do inside of replica slice is probably make this whole thing into a populate method instead of a new method, and we can reuse this code over there, something like that. What's up, Quiz IRL? Queasy? You were converting your pet project. Oh yeah, I saw you on the GitHub about the CI text. Yeah, I think we do actually need to implement CI text. I think the thing that we recommend is kind of not, it doesn't really work, as you know. I think I might have also giggled when I saw you on that issue. I was like, oh, now he knows the truth. But I do think that would be a good thing to fix at some point soon. So actually, why don't we start by making a method on replica slice that populates it? So we'll say rs replica slice, and this can be just a regular struct method, right? So we'll call it populate. We'll go like this. Or does it need to be a pointer? I'm confused. It's sort of like, I think this does need to be a pointer, doesn't it? Because we're gonna be, it might need to sort of, your goal or hope is to use the replica slice inside the gRPC transport as little as possible. Don't even like passing it to the constructor. let alone holding on to it. What does holding on to it give you on top of the v1? Okay, so right, the idea is that we'll be able to pool the allocation. I mean, I'm really just thinking about how to reduce the number of allocations, not anything else. You probably have something more holistic in mind, would be my guess. But what this would give me eventually is no, I wasn't thinking of pooling replica slices separately. I was thinking of pooling them along with the transport. So in other words, like the gRPC transport will be the owner of replica slice. We'll only pool gRPC transport, and then the slice memory that backs the replica slices will also be pooled inside of the gRPC transports. Does that make sense? I think that having object pools of objects that contain other pooled objects is an anti-pattern. I think that if you're going to pool a tree of objects, you should just pool the top of the tree and not the thing inside. Do you know what I mean? That's my thought anyway. But I don't really know. I mean, I definitely agree. You're suggesting two completely different pools. I see. So you're saying that the gRPC transport won't ever have anything to do with replica slice at all. The only problem is that it does need this replica slice. That's the only thing. That's the only tricky thing about it. It does eventually need to have a slice of replicas to touch. And so the question is, how do we ensure that that's happening? I feel like that there's nothing necessarily too horrible about having replica slice be held on by the gRPC transport though. I don't see anything too terribly objectionable with that, but I don't know. I guess you just don't like that it's got those node descriptors, right? That's the objection. These guys are gross and irrelevant to anybody. Yeah, I mean, okay, how about this as a crazy idea? What if it's worse than irrelevant? They look like they're relevant. Okay, so what if we hid them? What if we hid them then? What if we made methods on replica slice and the method, nobody accessed the replica slice via its actual slice, and people instead access it via some interface that hides away the node descriptors? Maybe that would make you feel better. I don't know. They look like they're relevant. Oh man, that is kind of sad, isn't it? That's why I think that V2 patch might have been kind of the way to go, right? Like your original suggestion was pretty good. It's having this struct with two slices. The slice is just used for the sorting, and that's the entire point. That second slice is really just used to do this sorting operation, and then you get to throw it away altogether afterwards. I just don't know if it really matters. I just don't know if it really matters. That's the trouble with this like ruthless pursuit of allocation reduction, is that you end up having to confront very existential questions, like what even matters in the code base at all. Yeah, exactly. It would have to definitely be paired with some trick where we avoid allocating anything at all, which could be this. I see, but then if at that point you know, yeah, exactly, yeah. If you wouldn't want to like pool that memory inside of the gRPC transport, because that like makes absolutely zero sense. So you'd want to have a separate object pool, but it just feels like there's too many object pools. I don't know. I'm just gonna, okay, look, don't kill me. I'm gonna try this out and see what it gets me. Where we pool this object inside of the transport. And we can just like not merge it, but I just want to see what it looks like. Okay. So I think what we'll do to make this happen, we'll basically copy the constructor code into this populate method. And instead of doing this, I think this also needs to be a pointer, right? Which is fine, I think. Especially if we're touching something that's been owned by another struct already, which it is. Maybe. Hopefully that doesn't make the owning thing escape. Well, that thing would already be on the heap because it's in the object pool. So I think that's actually fine. So I think essentially the idea here is that instead of making a new slice, we just check its capacity. We say if len of rs, I guess we have to dereference it here, or it's if capacity of rs is, no, we don't even need to do that, right? I think we can literally say, we just have to dereference it over here. Or does that break stuff? I don't know. Hey, Stray Basilisk, thank you so much for the raid. Welcome all of you Stray Basilisk watchers to Large Data Bank. We are working on trying to reduce some allocations in CockroachDB. And it's going pretty good. It's going pretty good. What were you guys doing on the Basilisk, in the Basilisk world? How did the stream go? We were just talking about allocation and garbage collection. Made a quad tree today. That's pretty cool. I've always wanted to learn more about the old quad tree data structure. I don't know too much about it. I understand those visualizations that people will post about the quad tree, but the truth is that I don't actually understand how it works particularly well or how to implement one. Those visualizations are pretty hot though. So, and instead of returning the descriptor or anything, we'll just leave at this point. Okay, so we'll say populate takes this replica slice. Populate, we'll say like
Computers hooked into over 1,000 data banks.
I guess actually over here we want to quickly like zero. We want to say rs is equal to rs slice to 0. Does this not make sense? I think this does make sense, doesn't it? Hey, thanks for the follow, Burkon. It's really neat. One of those things where recursion just makes it work magically. That does seem pretty neat. Populate adds replicas to this replica slice. What does the constructor say over here? It says, oh wow, it's like a big old fat comment. So I think we'll actually grab most of this and put it on top of populate. And then I think we'll keep new replica slice, but we'll have it invoke populate. So we'll say rs is equal to, see the thing is that this is gonna allocate now, but I think that we won't have to worry about this allocating much because I don't think we're gonna ever really use it. In fact, maybe we don't need this thing at all. Maybe we actually get rid of this. Well, we'll keep it just for tests and whatnot. Maybe we can mark it deprecated or something. Maybe we can get rid of it at the end of this patch, assuming that we even like the way this patch is going. But for now, we'll just have it. We'll just sort of have it work. So we'll say var replica slice, or var ret replica slice. Then we'll say ret dot populate, and we'll pass in everything. Then we'll return ret, or I guess we'll have to say error, return ret error. Okay, yo Denny, what is up? Okay, so that is that. What's wrong with this exactly?
The data bank's too big. I have to narrow down the search.
How are you gonna do that?
By guessing.
That doesn't make any sense. Is this a case of Goland getting confused, or am I confused? Love how chat is popping. I also love that. Chat, you guys are all great. Thank you all for hanging out with me. General Soak, thank you for the follow. Okay, so here in gRPC transport, the idea is going to be that.
Computers hooked into over 1,000 data banks throughout the world.
The White 1989. That is my birthday, 1989. Gonna get a new M1 Mac. I don't think I'm gonna get the first version of it. I think I would like to wait until things are kind of chilled out with the old, does anything actually work on ARM? They found an exploit. So, free root. So I think the next thing is we've actually got to add a new method on this transport. Now this is going to be the most annoying thing because there's like a million different users of this thing. Well, okay, here's another idea, right? Perhaps I don't know. I was gonna say like we could theoretically pass all of these arguments into our transport, but I think that that's actually extremely confusing because I think like from sort of like a conceptual perspective. So let's read what the transport factory docs say. Saw the news on this exploit. Man, oh man, these people love to exploit things, don't they? So transport factory encapsulates all interaction with the RPC subsystem, allowing it to be mocked out for testing. The factory function returns a transport which is used to send requests to one or more replicas in the slice. Yeah, so that's really that's like the real killer, right? That's the real killer, which is that yeah, now I think I'm maybe coming back around to it. Maybe I should have seen this interface first, right? Because the truth is that the transport factory, it makes no sense for the transport factory as an object to really care anything about what these like arguments are, like node descriptor store, range descriptor. It's just like random crap that we're passing in that like really is irrelevant from the perspective of this transport factory, which is really a very simple
throughout the world
thing. Yo, Morgan, what is up? Welcome to the stream, and thank you so much for that follow. Yeah, I hope you're doing good, Morgan. We're thinking about allocations, so truly the dream. Morgan, let me ask you a question. How went that project where you were playing around with Pebble? Weren't you playing around with Pebble? Did I make that up? Weren't we chatting on Twitter about how to do iterators or something? I remember we had a good conversation about that at one point. So I hope whatever you did with that went pretty good. That was you. Kind of want a MacBook Air, but 8 GB of RAM is too little. Yeah, that isn't very much RAM, is it? But yeah, I think the truth is that this makes no sense to pass in extra stuff. And so I think that what we really should do is pool these replica slices. I think Andre is right. But I think what that means is that we can probably merge this patch as is, the first one, right? I don't know. Okay. Hold on. I think this thing that I'm doing right now literally makes no sense. So I'm just gonna undo it. Definitely gonna undo that. Don't like it. Just get rid of all of this crap. It was misguided. 100% misguided. Get rid of this populate replicas. Using Pebble for the backbone of a distributed key value store that I'm working on works great. Wow, that sounds pretty exciting. A distributed key value store. I'm all about those distributed key value stores. You should pop into the CockroachDB community Slack and tell us all about it in the Pebble channel. What's your reasoning for using raw pebble instead of cockroach? That is a great question. I'm curious about the answer to that question as well. There were a couple of test failures on this original patch, though, which I want to look at. It says that could not analyze. Oh, I think they're probably the test package didn't compile or something like that. So let's just figure out why that's the case. How about? So we're gonna git fetch mine. We're gonna reset to this thing. Oh wait, we didn't re-push, did we? Well, truth is that I just don't know what to do exactly. Probably better off just using Cockroach. Used it before for a number of projects. Mainly just wanted to learn how to actually build a distributed KV store, so that's the reasoning. I think that makes a lot of sense. So let's go ahead and run the test against this. See what happens. Whoops. Yeah, the soup is cold by now, but it's still good. Microsoft's version of Minecraft uses LevelDB, and apparently it corrupts the save from time to time, driving some console players pretty crazy. That makes sense, because as a console player, what can you even do if you get a corrupted save? You're kind of screwed, right? Oh, does this need to be released? That is a good point. Indeed it does. I'm actually starting to think that why wouldn't we just, I think the truth is that the best compromise is actually to take one of your other suggestions, which is to pass in the slice memory into the dot descriptors thing. I think that would actually satisfy everybody, including me. I think I'm going to do that actually, right? Because what are the problems with that? I don't think there really are any. If we were to just pass in this particular slice, right? No, but it's still kind of hard though. I don't know. Everything sucks. Nothing is good. Everything is truly terrible because, like, look, in order to get back the slice memory from gRPC transport factory or gRPC transport, you have to already be inside of this factory impl thing, which is the one that knows about the object pool. And so now at this point, I've gotten the replica slice. But if I wanted to get this slice memory of the replica slice out up into, like, we're still passing in replica slice in a sense. So if we're already passing in replica slice, then like, what is even the point? It's just the same. Like, yeah. So it's a trap. I don't know. Everything sucks. Everything sucks. I have nothing to say. Besides everything sucks. Yeah, no, I understand. You pass an array into replica slice.descriptors, but the problem is that like you still have to pass the replica slice into the gRPC transport factory. You have to do that, or else you won't have the array to pass into the descriptors function. You know what I mean? Like, I think your argument is really about not passing replica slice into the transport factory. That's the key, because you allocate the array on the stack. Oh, like an array. But don't you have to know the size of the array statically to make a stack allocated array? Am I crazy? An array. That is interesting. That is truly interesting. I guess, I mean, it would work. You could just do some static size, and then if it got any bigger, then it would allocate. But like, I don't know. It seems mildly awkward. Right? Oh yeah, and this thing I've got to release. Where is this release business? Transport. Here I say transport defer transport dot release. I think it should work even if you call slice equals make. You think that should stay on the stack? I really doubt it. I think it'll escape. I think it will 100% escape, and the reason is that I don't think the Go compiler does the analysis exhaustively enough, because we're passing the slice into this like opaque interface method. So because it's an opaque interface method, I don't think it can statically verify that all the implementations of the interface don't let the slice escape. I think that's the issue. Everything sucks. Exactly. I completely agree. I'm glad that we're on the same page here. It really, truly is bad. Your only choice at this point is to write the whole thing in C++ or Rust. I think that would be the counter argument, right? Rewrite it in Zig. I want to play around with Zig. I hear good things about it. Who has an opinion about Zig versus Nim, though? Because those are the two hot 3-letter languages. Just rewrite in brainfuck?
Data banks.
Hey, Mife, thank you for the follow. Who's gonna make the first programming language that's just called sus? I would like to use that as my language. Nim defaults to GC, so you have Nim with GC and Nim without GC, and life isn't fun. Oh, you can like switch on and off the garbage collector or something? Is that what you're saying? Zig is more of a C replacement, while Nim and Rust feel like C++ replacements. That makes sense. It feels like a little bit disturbing that you can have a language where you can turn a garbage collector on and off. That's like just confusing. It feels, because garbage collection is just such a fundamental part of a language that it feels a bit odd to have modes where you can have it on and modes where you can have it off, but I don't know. I feel like Objective-C, I haven't done much Objective-C programming, or really like at all, any, but I seem to recall that they're pretty like, they have a lot of advanced things that you can use that will like, it's like an, don't they have like a, like objects that you can sort of garbage collect, but you can like put them into a garbage collecting pool or something like that, and it does a bunch of stuff for you, but like by default it wouldn't happen. People keep asking for Go with the option to turn off the garbage collector. I don't know if that makes any sense. Yeah. Okay, what happened here? Transport.go 303. Oh, dissender test 3012. Okay, so we're passing in an empty replica slice. Could that be the issue? Then we go into transport.go 303. Always send to the first replica. Huh? I'm a bit confused how this test could have worked then. How would you free your memory in Go without the garbage collector? I guess you would just have to everything would have to be stack allocated or something. You get malloc and free in Go instead of the garbage collector? That sounds pretty scary to me. I don't know. Pretty scary. And also just like object escaping, right? Like, oh, I guess maybe they would say that the compiler would fail if object escaped that you hadn't allocated or something like that. Like heap allocated, I mean. 3112. I wish more languages would do runtime optimizations of code like JVM.net. Or, yeah. I think that the people really like Java for that, right? People are like, the JVM is the ultimate thing. You just have, I remember when I was doing Java stuff, people would be like, yeah, you gotta let the VM warm up. You know, it's gonna run slow at first. You just have to let it warm up like it was a car. Nobody really understood what that meant, but they sort of had to do it anyway. And I think, I mean, it did work. It just feels a little bit magic, you know? It's like a little bit scary to have something that's that magic. Proper memory management in highly concurrent software is really difficult. Garbage collection is basically required. I feel like it kind of depends on what kind of application you're writing, maybe. But maybe not. Okay, so here the difference is that we've got to... Yeah, I don't see how this exactly would have worked, to be honest. Copy reps to replicas. Oh, I see what I did wrong. Wait, do I? What is this? No, actually, I don't really understand. People say Java can run faster than C++ because it can optimize over time, but it has other performance problems. Yeah, I mean, Java itself has a lot of allocation issues. Rust's memory management works in concurrent software, but you also have to deal with the borrow checker, which can feel very restrictive. Borrow checker is Bay. Borrow checker is Bay. Okay, what is this test doing? What is this test doing? It says, make a sender transport factory, or use the sender transport factory on an empty sender func and pass in an empty replica slice. And what it did before was pass in an empty slice. I don't understand this. Oh, this is not a, wait, what? This is not an empty slice. That's the problem. It's a slice of one replica descriptor. Okay, well that's pretty confusing, but I think to fix it, I just have to go like this, right? Okay, very confusing, deeply confusing. Okay, let us add this back and push. So the thing there was that it wasn't an empty slice, it was a slice of length 1 that had an empty object in the 0th element. Matt CDS joins the chat, says nerd, and then dabs. Nice. That, you did it. Get fetch mine. People forget that there is a large class of software that, oh, did I already say that? Why will that? Yes. People are all about the concurrency these days. Whoops, I have to reset. People are all about system software that scales, right? That's the only kind of software there is. The acronym was CANE. Yes, exactly. I forgot about that. I've yet to like add that to my my like automatic muscle memory. I did that earlier on the stream, but I forgot to do it most recently. Matt CDS. Ah. Well, I think what we'll do is we'll see if these tests pass, and then we will see what else to optimize. I'm really glad I saw that here. It will help a lot the next time I have to figure out how something works in GitLab CI. Okay, what happened here? Test split healthy, return something wrong. Okay, presumably I screwed something up. It's a real test failure though, which is I think more exciting than these previous ones, which have all been like, I did something super stupid. So let's see, line 278. Oh, I see. I think the issue here is that I can be using these health, unhealthy, right? Let's let me actually just run these tests locally because I feel like this is taking forever. The whole push up and make test package. What was it called? It's called test split healthy. It's kind of a toss-up. Is this going to be half faster, or is pushing it up going to be faster? At this point, this isn't going to work. This isn't going to work. Need to wait until I have my AMD Threadripper to be able to stream and compile Cockroach at the same time. We're gonna pass in the name of the test too to make it run a bit faster. So test split healthy. I don't think that that's actually gonna fix the issue though. Dual socket Gen 2 EPYC or bus. I have no idea what that is, Morgan. I'm afraid to say I am a complete noob when it comes to the hardware. So I wonder if I actually did something wrong with the new implementation of the health split healthy. That would be more exciting, right? So we swap our replicas. So I talked a bit about this earlier. Instead of using a map for the health map, which used to say, given a replica ID, give me whether it's healthy or not, we change it to be this thing called a fast int map. And it actually maps an index within its replicas array to whether it's healthy or not. So what we have to do is when we swap two replicas, we also have to swap the indexes within this map, or else things like won't really work. So what did I do here? I said old I would be get the health of the ith replica, save it in a temp variable, set the ith health to the jth health, and then set, oh, wait, what? Yeah, I think this is right? I becomes the jth health, and then j becomes the old I. So I think this is right. Okay, so then let's look at the less implementation. We get the ith health, we get the jth health, and then this line I also found pretty confusing, but I think I got it right. The diff, it used to say return I is healthy and not j is healthy. So now we have return I is healthy and j is not healthy. So I think this is right. And yet it still doesn't work, right? Okay, so what do we actually get here? N1S0 question mark, N3S0 question mark, N2. Wait, what? Oh, is this just a problem of the way that we run the comparison since we changed the types? I feel like it's gotta be that. Maybe. So wait, let's go back to our test. Send test. Reflect.deep equal. Okay, so I think that is probably the issue here. Deep equal. Actually, no, I take it back. These should really be equal. Is the issue that oh no, I mean these are slices, not maps. So the order is different. So definitely we screwed something up. Okay, so the endpoint was supposed to be what? The actual result is, this is the expected, right? And the actual result is this first one. So what we got back was N1 S0, N3 S0, N2 S0, and we wanted N3, N1, N2. So these all just seem completely different. Okay, what the heck? That's like truly disturbing. Truly disturbing. And what's also kind of weird is that we only failed a single test case, right? Like we don't fatal in this test if something goes wrong. So it's just one that went wrong. And it's this 01 thing, which I think probably means we expected 312. So it's the first test case. I think it's the first test case. And what's supposed to happen is that 3 is supposed to pop to the front because it's healthy. And these things are supposed to say unhealthy, so they stay. So it should say 312, and it says 132. Okay, I have no idea. It kind of feels like my less function is just wrong, but I'm confused because we did just look at it, right? I thought we sort of determined together that it was fine. Let us look carefully at the diff. Okay, split. Split healthy, diff. So instead of taking this map, we're taking a fast int map. Okay, instead of taking a map, we have a fast int map. Here, it used to say that we didn't have to change the health at all, right? We looked at this together just now because we were mapping the contents of this replica to its health, not the index of the replicas to the health. We're setting I to J, and we're setting J to I to swap them. Seems legit. Instead of less, we used to be getting the health of the ith replica. Now we're still getting the health of the ith replica. Vice versa for J. I don't understand this line of code, but I do think that it's supposed to be the same, right? So less. It says that we want to return they are less if the ith thing is healthy and the jth thing is unhealthy. So you put healthy. A healthy thing is less than an unhealthy thing. If they're both healthy, then they're equal. If they're both unhealthy, then they're equal. But if one is healthy and the other one is unhealthy, then they're less. And vice versa if it's swapped or something. But I don't know. Well, okay, and just to check here, in our actual test case,
The data bank's too big.
yo, dope
I have to narrow down
thanks
the
for
search.
chatting and for the
How are you
follow.
gonna do that? By guessing.
Well, I am baffled. I'm officially confused. Should we make some prints? Okay, here's the other really confusing thing, is that these other test cases don't fail. This is supposed to be 1, 3, 2. 1 healthy, healthy, unhealthy. And this is just the one that doesn't fail. I mean, I guess we can debug it. Should we debug it? I think this is a good use case for the debugger because I usually feel like I don't use the delve on stream because it's like too slow. But the truth is that delve is going to work fine on this really simple tiny unit test. So we can use a debugger. It'll be fun. We love debuggers. It does mean I have to recompile whatever this thing is. I think it's Geos, the library for geospatial data that we use. It's kind of sad. Like we made this big step forward by getting rid of RocksDB and replacing it with Pebble for not having to compile C++. And then we backslid concurrently because we had to support Geos. I mean, it's not really a bad thing, right? It's like we're very happy that we have spatial data support. It's amazing. I think the spatial data support was like the #1 most upvoted request in all of our GitHub's history. I think there's like, I don't know, hundreds of people clamoring for geospatial data support in CockroachDB. So I'm super psyched that we provided it. That is in 20.2, by the way, the release that just came out. But it does mean that when you compile, you have to compile this geos thing, which makes you like mildly sad. But I don't think anybody really wants to re-implement this whole giant library in Go. it would take forever. Hey, what wasn't it? Who's talking about quad trees? Look, there's a quad tree library. Dun dun dun. Does anybody know of some good DMCA free music that I can play? Matt Cherney is pretty great, but I'm tired of this album. Deeply tired of it. Need to pick something new. Gotta pick something fresh. Okay, so I think now that those dependencies
The
built,
data bank's too big.
oh my god, computer can't handle
I have to narrow down
compiling
the
things and
search.
playing that
How are you
alert at
gonna
the
do
same
that?
time.
By
Yo,
guessing.
Brain Dancer, thank you so much for the follow. Okay, but I was gonna say, now that I think that the C stuff compiled, we can just run this under the debugger and we should be good to go. So just a quick little compilation break. No problem. Okay, so we're gonna run this test split healthy thing and we'll put it in the debugger and we'll break, I guess, over here. See how things go. Gotta get my dual socket on. Make this part a little bit less intolerable. I still don't really see what I'm doing wrong, honestly. Really don't get it. It should be pretty obvious, I feel like. I mean, this is like, oh, I think I maybe know what it is, right? Is it that, yeah, this is getting copied. So this has to be a pointer, which means that maybe we're gonna introduce another allocation by accident. Oh, sad. Okay, so look what's happening, right? Like, these methods are operating over pointers to the fast int map. Okay, I think I can kill this debugger. I think I know what the issue is. 64 cores per CPU and 2 CPUs. Dang. Okay, that's a lot of processor. That is a lot of processor. Okay, so I think that what we would have to basically do is make this be a pointer, which is really quite sad. Truly sad. But we'll see what it does, I guess. I just think that now, maybe this can be stack allocated, right? Because I think that the compiler maybe can tell that this thing isn't gonna escape, but it also might not be able to. Okay, screw this. We're gonna push it. We're gonna push it. We're gonna push it. We're gonna do it on this other computer, which is just so much faster. Yay, okay, so we fixed, okay, you guys, we did it. We figured out the problem, but now I'm a little bit concerned. the concern, okay, you know what we can do is actually, we can run, do you guys know about go build-m? We can run this with go build-m to figure out whether or not this thing is gonna escape or not. So this is kv chord. So we should be able to, whoops, what happened? Directory not found, kv server, oh, it's kv client. Okay, so the purpose of this is that we can actually statically determine whether or not this health map is going to escape to the heap, which would kind of defeat the purpose of making this a thing in the first place. So hopefully it will not escape to the heap. And then we can validate our hypothesis by running the benchmark again. So we're making progress. It's slow but sure, So we're gonna have to look, I guess, for maybe this line 124, because this is where it would escape. So transport.go. 124. We have to go 124. Health escapes to heap. God damn it. Okay. That is truly sad. Why? Why? It's so sad. Okay, so the reason for this is what exactly? It's that, I guess since we're passing in by health, this thing ends up getting heapified, right? Man, that sucks. Oh, you know what we could do to fix this? Oh, I know what we could do. Oh, we're still good, you guys. We're still good. We're still good. We're still good. We're gonna stop passing this by pointer, but we're actually gonna make by health be an allocated object since it's gonna have to get allocated anyway. Okay, this is good. This is good. So here's what's going on, you guys. When you pass something into sort.stable, since it takes in this interface, if you pass just a regular struct, the Go compiler is forced to allocate an object for this interface to be implemented by, or something like that. I don't totally get why that has to happen, but it's definitely true. So if I were to just pass in this by health object on its own, that was going to make an allocation no matter what. But it gets us into trouble because then when we're actually doing this swap operation on the by health struct, we're mutating part of a copy, so it doesn't like work at all. This has to be a pointer. But so I think that we can actually just pass a pointer to, we can take the address of this new by health object when we pass it to sort.stable, and this will allocate, but it's not going to be any more allocations than it was before. So I think we should be good to go. This one can become on a pointer, and then this one can become not a pointer. And then I think maybe that will help, maybe. I don't know, this stuff is tricky. Not this one. This stuff is a bit tricky. But you gotta get it right. You gotta get it right. Okay, so let's run go build to see what it tells us this time. This time, by health literal escapes to the heap. But that's inside of split healthy. It's just confusing because I think it's inlined. But I think that's fine. That is actually fine. Yo, James Harries, what is up? Welcome to the stream. All right. By health swap ignoring self-assignment? What does that mean? Ignoring self-assignment? I've never seen this last message before. Ignoring self-assignment? What the heck? What is this? I'm actually very confused and curious by this. So I'm gonna Google it. Generalized self-assignment handling and escape analysis. Oh, okay. Okay. So this is just like some debug messages about whether or not we need to think about escape analysis for this, and we don't. Okay, all good. Let us add these things. Oh, git cane. Never forget the git cane. Git push fmine. Okay, so first we're gonna run that unit test to make sure it still passes. I'm not exactly sure why it takes so long to recompile that. Okay, great. So it still passes the test. So let us go ahead and make build so we can have a test binary to run the profiler on. And then maybe, just maybe we could get out of this particular patch which would really quite be nice because we've been working on it for like an hour, 2 hours or something. What is the thing that allows you to walk through previous similar commands? You're talking about this control R thing. So all shells, I think for the most part have a control R, but this control R is done by FZF, which is a pretty cool program that is sort of generalized fuzzy find. So control R already is sort of a fuzzy finder, I think, or maybe it's just a prefix finder for previous shell commands, but what this FZF thing does is it just fuzzy finds through my entire bash history. So instead of having to just search for the prefix, I can also search for something in the middle, or even like some random stuff like this. I'm just typing pu-f and it gives me push-f. So if you want to figure that out, I think you can go to the FZF website, FZF. This is like such a cool program. I'm a big fan of FZF in general. I also have it set up for searching for files. So if I hit Control F, it's going to complete anything under my current directory. So I can be searching for like dissender or whatever, and it's going to give me all the files that are called dissender. And it also gives me a little preview. I never use the preview, but it's pretty neat. I think I can scroll the preview actually somehow. Check this out. Check this out. I'm scrolling a preview. It's so legit, except I never use this, but it's pretty legit. Anyway, okay, so we're gonna run our program. We're gonna run our load generator.
The data bank's too big. I have to narrow down the search.
How are you gonna do that?
By guessing.
Yo, Cyber Mentee, thank you so much for the follow. I will say that this load generator can be confusing because kind of want to watch these operations per second, but I feel like they're super, super noisy. Hey, Wacholderbear, see you later. Thank you so much for stopping by. Have a good weekend. All right, so what is up? What is up in our pprof? The thing that is up is here's our new replica slice that we've been debating for hours. Here's our transport factory. The truth is that I think, okay, we really want to look inside of the transport factory. So to do that, we can if we focus this again, we'll probably see it. It's kind of confusing sometimes, like the pprof will hide nodes that don't do a lot. But yeah, all right, so I guess what we've done is we've successfully deleted all allocations from this factory. This is like the allocations. You see how it says 0 of some number? That's because this function didn't make any allocations. This function made a very small number of allocations, and the number that it's making is the pooled object. So you can sort of tell that this object pool is working. And then down here, we make a bunch of allocations because we have to do that stupid sorting thing that we've been talking about. So if I click view source, whoops, this is not working because it's inlined, I guess. That's always pretty confusing. This thing doesn't really quite work if it's inlined. But if I guess I can look at the view source for the parent, and we'll see that split healthy is the thing that takes up the allocations. If you look inside of it, well, I think this thing just doesn't really work when you have any inline functions. They're like source viewer. Basically doesn't work at all. But I'm pretty positive that you would be able to see that the allocations are coming from this spot where we do sort that stable, right? We have to make an allocation.
I have to narrow down the search.
How are you gonna do that?
By guessing.
Yo, Schnitzel, thank you for the follow. Okay, so I guess I'm happy with this. I think we should be happy with ourselves.
The data bank's too big. I have to narrow down the search.
Hey, thank you for the follow, Big Booty Snatcher. What a username. that is. I think we should be happy with our progress here. Okay, so let's, you know what we should do next is come back up to this global view and see what is the next area that we would love to concentrate on, right? We've spent a bunch of time on this sender, and I think we've done pretty good. So the question is, what should we focus our efforts on next? There's some things, okay, check this out. So I did file an issue. You made it to troll on your friend's Twitch and you just kept it. I bet you got some good reactions from people, especially people who are reading out their follow messages. So here, okay, right? Like what's going on is that we've got for our benchmark, we've got, why don't we actually focus on this top level thing? So then this is actually going to show us 100% of the allocations in this read path, which is sort of what we're concerned with right now. And so the question is, what is a big percent? What's like a big fat percent that we could start concentrating on? I think the truth is that in many cases, there are no big fat percents to concentrate on, which is like the sad truth of the matter. But I think that for our purposes, a big fat percent is probably like between 1 to 2% of flat allocations. What's funny is that like these guys, this is like our big fat offender, the context.withValue, which like I really truly hate, but there's nothing there. We have some strategies that we have to like get rid of allocations in context with value, but they're like a little bit more involved, so I'm not going to mess with it. Like context is this thing in Go that lets you basically have extra key value pairs in your stack that like appear and disappear at different points in the stack, more or less. And we use them for various things like keeping track of what statements being run for like log tags reporting and stuff like that. And it's just like egregious that we keep allocating these things. So there's some ideas, but we're not going to mess with that on the stream. With cancel is similar. And I don't think we have any ideas of how to fix that. It may not be that important. I think last stream we spent a bunch of time looking at this path. Maybe we could look at it a little bit more. Well, maybe not. So what happens is that you follow this all the way down to the bottom and you end up with things that are really supposed to be allocating memory, like these guys. These guys are essentially the part of the code that's allocating areas for SQL data to live in, which is definitely a good use of our allocations. We do have plans to make like a big fat pooled set of data slices that can be reused over and over again, but that's like way outside of the scope, because we've got to think also about like, how do we actually account for all of this memory, which is a very important part of how Cockroach works or doesn't work, is like, what pools of memory are we sort of tracking? I wonder if we could look inside of this though, txn kv fetcher. Actually, I'm kind of curious about what this 1% is. So actually, let's take a look at the source view for this function. What is it doing? What is it doing? Oh yeah, this thing. Okay, so this is an interesting case. This is an interesting case for sure. So let's talk about the txn kv fetcher. This is a object that is actually the thing that comes right on top of the function that we were looking at earlier, the disk sender. What it does is it is the thing at the bottom of the SQL translation stack, in a sense, that takes. So what, okay, basically, sorry, this is like making literally no sense, but the way Cockroach works, right, is that it's this big SQL engine on top of a key value store. And queries are SQL queries that are transformed through a long sequence of, tubes, in a sense, into commands to this KV layer. And this transaction, txn kv fetcher thing, is essentially the very bottom of SQL right before it turns into KV. And I think, in fact, we were just really talking about this earlier, but basically, like this thing that's allocating that I'm going to show you in a second, ba.requests, what this is actually doing is it's making these sort of request objects. You can imagine like when you send stuff to a server, you have to send it some data about like, hey, what do I actually want? So maybe it's like, you know, your HTTP requests, or in this particular case, it's our gRPC requests. And I guess what we do here is that we actually have to make a request object per span. And a span is a, it's kind of like, I'll show you actually in the SQL shell here real quick. Whoops, C demo. I'm gonna make a table, A int primary key, B int, insert into A values 1, 2, 2, 2, 3, 2. Okay, so I've got some values in my table. And if I were to use explain on a query on this table, explain select star from A where A is equal to 2, this is gonna give me this span thing, which is saying, what's the range of values that I'm fetching from my index? In this case, I specify that A is the primary key of this table, which means that there's going to be an index on this table from A to B, basically. And since I've asked for the values where the rows where A is equal to 2, I'm going to make a key span from 2 ending at 2 to fetch. So if I said where A equals 2 or A equals 3, it's going to be a bigger key span that includes 2 and 3. Okay. And if I included things that were non-contiguous, if I said where A equals 1 or A equals 3, you'd see there's actually, well, this is actually surprising. I think this is because we know that the table's really small that we're doing it like this. The optimizer has made the choice that it's going to be more efficient to just scan the whole thing and do a filter than to do precise lookups. But let's say I inserted way more data into the table. Insert into A, select G from generate series, and we'll do 4 to, oh wait, this is not how generate series works, is it? Wait, is it? I actually forget. Anyway, so we'll insert like 10,000 values into this table. And then we will do the select. Okay, it's still the same. The heck? Is there like a, let's see.
The computer's hooked into over
How
1,000 data banks throughout the world.
Is it this create statistics? Man, I forget, like, there's this new thing where I can ask it to create statistics for the table. I just don't remember what the heck the statement is. Is it create statistics? There's inject statistics. That's not right. Yeah, I think it is. Create statistics on A? On table A? I don't even know my own database. Create statistics from. That doesn't sound right either. There, man. Yo, damn dude, sometimes I think I'm getting better programming. Oh, don't worry. You will definitely, I think I've just been working on this project for like way too long, so I understand how it works, but you'll, just takes practice. Just takes practice. Keep practicing. What the heck? I just don't remember the syntax for saying, please do a scan over the table to refresh its statistics. Oh, is it refresh statistics? Refresh statistics on A? No? Refresh? Is there a refresh? No, there's refresh materialized view. Anyway, it doesn't matter. The point is, in the background, you guys, while I was just confused about that, forgetting like what even the syntax is, it did, it's not analyze Greg TBUI, but that's a good suggestion. I don't think, is it analyze? Is it? Oh my God. It totally is. Greg, you are my savior, and I apologize for calling you wrong at first. Anyway, so as you can see, in the background, it did refresh, it did analyze, and because it knows that there's a lot more data in the table, since I've asked for this disjunction, give me all the rows where A equals 1 or A equals 3, it actually made 2 spans. That's the only thing I wanted to show you guys. Look, in the spans, you can see it's going to search for 1 to 1 or 3 to 3. Okay, so back to the code. And 0day99, thanks for the follow 2 minutes ago, by the way. Back to the code. It turns out that in this txn kv fetcher thing, we're continually making new slices for that in the size of the number of spans that we're going to be checking. And that just feels like maybe we could avoid it, right? Like this txn kv fetcher, I know this thing happens to be scoped per query. So like this is not a singleton or anything. Like we have one of these that's freshly instantiated for the whole query. And I think it's just like a single threaded little guy. So I feel like this is yet another place where we could avoid having to make new slices all the time. Use an object pool. And in fact, don't we already object pool this thing? Am I completely crazy? Maybe I am completely crazy. Maybe we should be object pooling though. Because like, look at all these slices that we could be saving. Make KV batch fetcher. We definitely do not use an object pool here. Definitely do not use an object pool here. Should we? There's a question. There is a question. Why don't we look, where do we actually make these things again? New KV fetcher, which is in C fetcher. So start scan, right? This should show up in this chart for sure. Where is it? Does not show up. Why is that? Where's my start scan at? Maybe I think if I maybe isolate, if I zoom in on this guy. Aha. Okay, so it's inside of here. Why don't we focus on this thing then? Focus. Okay, I don't know. I mean, is this important? Is streaming part of my job? That is a very interesting question. I would say that I've made it part of my job. Since I think it's some good DevRel where I'm getting the message out, I'm doing my thing. We've got this Flex Friday policy at this company, which is pretty nice. It sort of lets you do, you know, it's kind of like the Google 20% time. It's like things that are sort of relevant to work in one way or another. So I'm sort of doing some work, mostly like during my like normal day job thing. I'm a engineering manager. So I am Amint. Did I just say Amint out loud? I'm not really doing too much coding day to day these days. So on Friday, do some streaming, do some DevRel, do some coding. That's kind of my jam right now. I'm making it work. I think it's pretty good. It's a good arrangement. I appreciate the flexibility quite a bit. I think the truth is that this whole pathway is extremely allocation heavy. Right? Like, couldn't we pool this whole object? Wouldn't that be crazy? Wouldn't that be so cool? Or is it just like too much? Is it just like way out of control? I feel like we really could pool it, couldn't we? Am I just being a little bit too ambitious though? Because I know that all of these objects, yeah, see, this is the thing, right? It's like all of these objects get sent to the lower level one, but this upper level one, we could be pooling it. We could be pooling it. And what's better is that we could actually be pooling it up here. So instead of storing this as a pointer, we could be storing this as a non-pointer. I think that's going to make our lives a lot better. Optimistically, right? Why are we even using this? Why do we even have this as a function? We should not have it as a function at all. We're going to get rid of it. Unless we sort of need it for the purposes of let's take a look at the allocations in this guy here.
Data banks, data banks, data banks.
I do use Vim key bindings. Indeed I do. Yo, Algol, thank you for the follow. Too many arguments for the constructor, it looks terrifying. It's not really that bad. Sometimes you just gotta pass parameters, you know, there's nothing I can do about it. I do, yes, exactly. I do use the Golang, Goland. The minimal view, not too many toolbars, task bars. I know it's bad. Okay, I'm gonna fix that. I knew that somebody was okay, we're fixing it right now. I knew that somebody was gonna complain about this. Okay, so commands edit IDE. Okay, we're gonna fix this right now. Go IDE. What the? It's actually very hard to use this text box. Well, bam. How about that? Oh God, I think I just typed the. Okay. Edit. Commands. Edit. IDE. Bam. Okay, how about that? What the heck? Oh my gosh. I'm really struggling here, as you can see. All right, we're doing it. We're back in business. All is well. All is absolutely well. It is the idea Vim plugin. Yes, it absolutely is. How come I can't see? I want to like focus. Do I guess I just ignore this one, right? Ignore this guy. Ignore. It does? What? You're right. What is wrong with it? What is it? Is this some sort of eventually consistent? This thing is a piece of crap. Do you think it's the double exclamation point? Oh man. I'll have to fix this. I'll have to fix this. This is an absolute disaster for my personal brand. Everything is ruined. This thing is making it difficult for me to zoom in on the right parts of the code here. Show from. That's almost right. I think I want to use show from. Yeah, let everybody know. Just let everybody know about this. I'm going to be banned and absolutely decimated. Okay, show from. Now this is a good function to know about. So show from allows you to click a node and give me the entire stack below that particular node, which is pretty much what I want. So what this is telling me is actually something very confusing, which is that apparently this thing doesn't allocate at all. I guess that makes sense. I guess this is the one that is going to be returning something that this is where it's going to escape from, I guess, or something. Let's see what it has to say about itself. It's actually kind of weird. It's actually kind of weird. It doesn't say that that particular thing is escaping at all, which is say a little bit surprising. I think maybe it's a good thing though. Maybe all we have to actually fix is this weird send func crap, which seems like imminently fixable, right? Like what is going on with this and can we fix it? It seems kind of like we have a closure and we're passing the closure in. As we all know, closures are bad because they allocate needlessly. So what would we need to do? The only thing that is closed over by this send func is this transaction, I think. So can we somehow make this, what can we do about
The
this?
data
What is
bank's
this
too
send
big.
func all about?
I have to narrow down the search
How are you gonna do that?
by guessing.
Hey, Milu, thank you for the follow. The send func is the function used to execute a KV batch normally wraps client.txn send. Okay. So I think that the pattern that we really want to be using here is instead of sending in a function, we want to be sending in an object with a method, because that's going to avoid having to, let's just undo this for now. I think let's concentrate on this send func. I think that seems like an easier thing to fix, potentially. Potentially. Instead of passing this closure, what we really want to do is pass an object that can kind of call itself, right? And I think that in this case, wait a minute, can't we just pass in? First of all, couldn't we just pass in txn.send? Wouldn't that work? It doesn't work, why? Cannot use oh, it's because it's the wrong error type. That's kind of interesting, right? So I think what we could do here then is make an object called type sending txn. Yo, Korean Doctor Strange, is this the code to kill Joel? The answer is yes. The answer is yes. We're gonna make a struct called type sending txn struct. It's gonna wrap a txn like this, and it's gonna have a single function called send, func sending txn send, and it's going to take our context.context, and it's our ba roach pb.batch request, and it's going to return a batch response error, and it's simply going to do exactly what we had up here in this closure, like this. Okay, so the purpose of all of this is that we really want to make it so that, so I think that if at this point, if I said s is equal to, or if I said like wrapper is equal to sending txn of txn like this, I think that this wouldn't actually help if I said wrapper.send, because I think that this is still going to have to allocate, because this is technically going to be a closure that includes s, right? So Oh, you know, this, we might not be able to really get away with it, because what I was going to say is that what we could do is change this function. So instead of taking a send func, the idea would be that it would take a new, so it would take a sender, type sender interface. Whoops, putter, what the heck? And this will basically have this same method on it, right? Send blah, blah, blah. And then this thing can take a sender. So instead of a send function, it's a sender. And then down here, we're gonna say, oh, this thing also has the same problem. So this is also gonna be a sender, right? And then this is broken, yes. This is gonna be like this. And then here we say f.sender.send, right? That's the point. Sender. Okay. The only thing, and then of course here we're gonna just pass wrapper. The only thing is I think that this is still going to allocate because sending TXN is going to not be, well, will this still allocate? I actually don't know. Guess we can find out. Why don't we find out? So we're gonna use our same technique from before. So we'll say go build mm, and we're gonna pass in package SQL row like this. Then we can search to see whether it allocates or not. Fun stuff. Fun stuff. Okay, what happened? Send func does not implement sender. What? I think I just like didn't finish changing all these. Okay, so there's like a few other callers that we have to mess with. Okay, so send func. Send fun. Okay, you see, like this is like super sketchy, I have to say. Big old fat closure where what we really want to be doing is making an object that implements sender. So let's actually go ahead and do that. So we're gonna make a type inconsistent sender struct. And it's gonna have to have all of the stuff that this thing needs, right? Let's just see what happens if we just copy paste this whole body. Oops, this actually, not quite right. So func ctx context.context, whatever, I forget what it was exactly. And it's gonna be I inconsistent sender, send. What does a sender also have? It's a, this whole signature, right? So the signature is really this. Okay, so what is all missing? We need to have a TXN timestamp inside of this thing. We need a max timestamp age. We need a TXN. Oh my God, wait, does this actually edit? It can't possibly edit. No, it doesn't, right? Hey, BJ Kegley. Thank you so much for the raid, my friend. I hope your stream went super well. And welcome to all the BJ Keglians. What were you guys up to? BJ Keg Pizza Tank. I like that quite a bit. Is that like a little pizza firing out of the tank hole of the tank? Like a little pizza slice with some pepperonis on it, maybe. But I hope you guys had a really good stream. What were you guys working on? What is up? What we're working on today is we are going around trying to slaughter a bunch of extra pointless allocations from CockroachDB's read path. It's basically going, okay, building a tree sitter grammar for GraphQL. I think I remember you maybe telling me about this from another raid, or maybe I just saw it in your stream description a couple of times, but that sounds pretty sweet. That absolutely sounds cool.
Databanks, databanks,
Hey,
databanks.
Ali Reza, thank you for the follow. So I would say overall, this is going like, I don't know, it's going like fine. I feel a little bit confused about whether this is going to work as a strategy. Does this code path get executed by a single Go routine? Yes, it does. That is a great question, and the answer is yes.
The data bank's too big. I have to narrow down the search.
And so what is
How are
this
you
going to
gonna do
be?
that?
It's going to be
I'm guessing.
a HLC timestamp, right? Very cool. Okay, enjoy. Thank you for the raid again, and I'll see you later. You know, you guys, I don't think this strategy is going to work because I'm pretty sure this is just going to still have to allocate, right? I think I'm gonna, okay, here's what we're gonna actually do. Since this thing is actually sort of a rare path, I actually think that what we should do is instead of making, we should make a functioner in a sense. So here's a pattern that we use a lot, which is where, you know, we have this thing to implement. Let's go back to where we implemented it actually. So our sender, right? I think what we'll do is we'll essentially make a, we'll say func sender func sender, I don't know, func sender. It's going to take a send func, right? And it's going to transform it into one of these objects, just so like we can have interoperability with the old method. Context.context, PA roach PV. I guess we should just copy this. Okay, and so this thing is going to return a sender. And the purpose is so that we can actually make a sender out of a function. Are these Go routines pooled? Meaning, are the, what do you mean by that? I mean, the answer is basically not really. If you're thinking of like a thread pool from Java or something like that, we don't need that really so much because Go routines are so cheap to create and delete. Is that what you meant? Are they spawned per request? Kind of. So I would say like not really. Like the way that SQL works in general is that you hold open a big connection to the database when you're doing anything with a database. And so that there's like a couple of Go routines that are held per connection. Sort of there's like some sender ones, some receiver ones, and like some other stuff. But they stay alive for the lifetime of that request, of the connection, my bad. So if you do a lot of requests on a connection, you're not spawning new Go routines. Well, it depends on the query, but for the most part, if it's a really simple query, you're not spawning any fresh Go routines on every new query. We do spawn new fresh Go routines if you're doing sort of like a dist SQL thing, which is like a distributed SQL query, but that's going to be expensive anyway, so it doesn't matter. Why not implementing send on send func? Oh, that's actually a really good idea. That's actually a really good idea. Oh my gosh. Very, very, very smart. I didn't think of that. I didn't think of that at all. That is a very, very good point. Okay, so let's see. The idea here is that we're going to say func send. Wait, does this make sense? It's a type. Can you do this? Does this work? This is actually very cool. I didn't know about this pattern, but I like it quite a bit. So this is going to be return s of ctx pa. Oh my god, that's awesome, dude. That's so cool. Actually, That's such a handy little pattern. Okay, very, very neat. Okay, so then we can get rid of all of these changes. And then everything just works. That's actually super cool. Wow. I love that. I don't even think we need this, right? I guess we do for some reason. Why is that? Why do we need that?
Computers hooked into over 1,000 data banks throughout the world.
Weird. Hey, Starbucks, never know. Thank you for the follow. Yeah, you need to cast it. That makes sense. Okay. So let's try our Go build again. See what we get. Okay, so at least we are compiling. That's such a cool trick, man. I'm a big fan of that. So this code gets executed by a single connection worker go routine or something like that. Basically, yes. Like for the example that we were working on, where create table. Like let's say we ran this query like we did before. This query path thing will get all executed just by that single connection go routine that's sort of dedicated for this connection that's open. Like all of the queries that I'm running right now in this example shell are all getting executed by the same go routine. I guess in real life it would be slightly different because I would be, you know, this would be a client, there would be a server, but in any case, like there would be a server go routine that's like doing all of this work, you know, doing the optimization for this query and then actually executing it all the way down into this fetcher thing that we're looking at. It gets a little bit hazier because since it is a distributed system, if the query has to go to different nodes to satisfy these responses, which happens all the time and is totally normal, then of course there will be extra go routines on those nodes that are getting allocated. But if it's the case that it's all local, yes, it's gonna all get executed by that single go routine. Okay, so let us see now. Did we actually manage to save anything, or is it just sort of the same problem? We wanted to, we had this wrapper, right? So this is gonna be KV batch fetcher line 202. Parameter txn, okay, this is not, do I only need a single dash m? Like is the double dash m making everything really hard to read? I feel like the answer is yes. Whoops. Let's try that one more time. What is this line 202, right? Maybe we just search for it directly. I sort of thought that we would need to look nearby, but maybe we don't. .go. So that's actually cool. I think that means we don't actually allocate there. So we did it. That's neat. That's neat. Why don't we actually make a, okay, so we're gonna make a new branch for this. Get checkout -b sender func allocs. So we're gonna say row. We're gonna say basically like reduce allocations or remove allocations for sender func. I mean, this is just not gonna be like a particularly comprehensible commit message. So maybe we should do something like reduce allocs in KV fetcher constructor, something like that. So restructure the constructor for KV. Some code in the KV fetcher constructor path to remove a pointless closure allocation in the common case. How about that? Okay, so we'll push this up, and in our remote machine, we'll kill the server, we'll fetch. We're gonna reset, except actually we're gonna check out now. So we're gonna check out sender func allocs. We're gonna build. All right, okay. Yes, as Just B pointed out, it's Goland, which I can't change that command to say go instead of Golang, but you know what I mean. Hey, Daito Main, thank you for the follow. Appreciate that. Okay, so now that this is going, let's go ahead and collect a new heap profile and see if we made any differences. The answer seems to be yes. So remember, we used to have some allocations here and then some allocations down here. Now we only have one down here. And let's take a look at what that one is. It's presumably making this fetcher object in the first place. Oh, it's actually not. It's actually this copy spans thing, which I'm hoping that we can get rid of this too, potentially, by using some trickiness. And I think we can definitely do it. Okay, I think we're making some good progress here. I'm feeling good about it. So check this out. What's going on? If you recall, these spans, this was the object that has that information about which things that we need to actually sort of fetch from the database. We'll recreate our demo, explain select star from this, right? Hey, MTZ Junka, thank you so much for the 100 bits. I really appreciate it. So these spans here are what we're talking about when we are talking about spans. And as it happens, it seems like we have to copy the spans because we're going to edit them. And I don't exactly know why that would be the case. Like, why would it be important that we're not to edit these spans? Maybe we should find the answer to that question out before we continue. I think we should. Because it feels like, I mean, naively, it kind of feels like it should be fine to modify this input spans argument. Spans comes from here. Spans comes from here. I mean, I guess it comes up pretty far up from the stack, but like, I guess I just don't see naively why we would have to worry about not modifying those things, right? I don't quite understand that, because these are just, okay, well maybe, I mean, it seems like, okay, so when we make a new one of these guys, we send a whole bunch of spans in, we add them up into a slice. And then do we ever update this slice again? Because if we didn't ever update this slice again, then I would say that it's completely fine for us to edit them, right? Shouldn't that be okay? Here's where we do iterate over them again, but it doesn't, I don't think it would matter the order in this particular thing. So, I mean, to me, it kind of feels like, I just don't know if we really need to make this copy. Make a copy of the spans because we update them. Is the problem that we actually edit the spans though? Because that could be bad, right? Is that the issue? Do we actually edit the spans? Oh, we add things to them as well. Okay. Maybe it's not so good then. I think that if we have to add things, that is problematic. So the reason, oh yeah. Okay, so I remember what this is about. Basically, okay, so this is actually pretty cool. This is going to teach you quite a bit about how Cockroach works under the hood. So if I had a giant, let's pretend that this table had a huge number of values in it. Actually, we can just go ahead and make it. So we'll insert into A, select star from generate series 1 to 1,000,000. So we'll put 1,000,000 values in here. Whoops, insert into A. So, okay, so let's say I wanted to actually select like the sum of A from G from A, like this. So what this would do is it has to read all 1,000,000 entries from the disk and sum up their values. And I think that what actually has to happen under the hood, I think the reason that this is slow at first is that when you have these really big inserts, things get kind of sad and they have to clean up some intents or something like that. I think like, this is something I've never actually understood, to be honest. It's like if you use a really large batch size as your inserts, like the select will get slow until something gets cleaned up. I actually don't understand that. I wish that I did. Normally when I think the second time it'll be like significantly, yeah, like what the heck? So I mean, this is such a bizarre thing. I feel like I should file an issue about this because it's just so baffling. Like 35 seconds versus less than a second? Question mark? It's something about these intents, but anyway, whatever. It's not that important. The point is that under the hood, when I do this select, it's not going to fetch all 1,000,000 rows into memory at once. It's actually going to like page them in because we don't want to have to store all of the data in memory to do this streaming calculation. So the way that that works under the hood is that we're sort of like, imagine an iterator over the database. We ask for like, give me a bunch of data, but then give me like, put a limit on it essentially. And when I hit my limit, give me back a span of the keys that I haven't looked at yet. And so that's what this resume span business is about. It's saying, I know that you asked for the entire span from 0 to 1,000,000, but since you also asked for a limit, I'm only going to give you back that limit's worth of data, and I'm going to give you back this resume span of the data that I haven't given you back yet. And that's how this thing can sort of be an iterator under the hood. That all being said, what we do is we actually add to this internal set of spans this resume span. And I think that if we did actually mutate the input set of spans, that would be like really deeply confusing for everybody. So I guess I sort of see why we do make a copy. Okay, so what can we do about that? Spans do not have a view copy on write option. I think the issue isn't the spans themselves. Like the spans themselves, I got a little bit confused. The spans themselves aren't getting mutated. Like, okay, here's the thing that's confusing. There's an object called roachpb.spans, and it itself is just a slice of span. And so the individual span objects are not getting mutated. What is getting mutated is this slice of spans. And I don't think, but yeah, I suppose like you're right. You could maybe put a copy and write thing on top of this slice, but since it's just a raw go slice, I guess we haven't really done that. I don't know. Yeah, the slice itself. I don't know. Yeah, that's a good point. But that's an interesting idea. I mean, can I help you get back a hacked Facebook account? Casey's load. I'm sorry to say that I cannot help you get back a hacked Facebook account.
Database.
But thank you for the follow anyway. Thank you for the follow. So what I was thinking is that, we could potentially cache the memory for this span copy, right? Like as we've been sort of talking about this whole time. Instead of making a fresh slice and then populating it in here, which we do already, right? Like this, essentially like we could pool either this object or the object that it is a child of. You need to go to Mark Zuckerberg's stream. Yes, Casey, if you can find Mark Zuckerberg's stream on Twitch, maybe he could help you get your Facebook account back. Doesn't Mark Zuckerberg sometimes stream himself like smoking meats? Or is that just more of a one-time thing? I'm not exactly sure. He streams on Facebook. Good point. Wait. Or yeah, Facebook gaming, right? There was something like that. Hacking Facebook databanks poggers. Yeah, I mean, in general, one thing that I'm like a little bit confused about is like how we managed to not let this whole thing escape. Like, could that really be true? So why don't we actually jump back out into a slightly higher view here? Actually, let's just go back up to the top again. Because if those things didn't escape at all, actually that'd be pretty sweet. But it just sort of shocks me. Does this search thing work? I haven't really played around with this search thing, but I would like to try it because it would really help right around now. Start scan. It does work. That's pretty cool. Okay, so the new KV fetcher, this is the thing that presumably where everything escapes out into the heap. Right? Now this is just silly. You see, we're making an object and then we're enclosing it into another object, both of which have to allocate. So we've got to do better, team. Team, we've just got to do better. Okay, so make KV batch fetcher. This thing is now going to be pooled. We're doing it. We're going to make it happen. Okay, so txn KV fetcher pool var is equal to sync.pool. Okay. Probably don't need to have this all in one line. A little bit unnecessary. Okay, so here though, this is where we get to save all the good memory, right? Right, and so this thing is now going to return a pointer though. That's the whole point. That is the entire point. You built a visualization tool for the project you were working on. Oh, are you talking about this whole thing? This, I didn't build this. This is called pprof, and it comes with Go. And also I think you can use it on C++ and other stuff too. I didn't build this. That'd be sick. If I built this, I would be feeling pretty good about myself. But I think that this pprof thing is kind of like an older project. Hey, Rob Matt X, thank you for the follow. Okay, so I've got my ret, and I'm going to say, I've also got to make a release function for it, right? I've got a close. So I wonder if I should probably make this also call release. Or I can just do it right here, maybe. I guess, yeah. Well, it takes a lot of people to build a database. A lot of people. So So the only thing we're going to cache in here, we can cache two things. We can cache quite a bit, to be honest. Well, so okay. So responses, I don't think we allocate though. Responses gets sent from us. So we're not going to save this one. Request spans. This is... Wait, what's going on over there? What's going on over here? What is this? Oh, this is interesting. So I think what's happening here is that we are saving a little bit of our own memory, but it's only when we reuse the transaction KB fetcher. What we really want to do is reuse it more across requests. This is just reusing across multiple fetches to the same request, which is good, but not as good as we could be doing. Okay, so we're gonna reset our TXN KB fetcher, but we're gonna save those requests, right? Wait. Request spans like this. Get rid of this. Are there other fields that we wanted to cache, right? I think these ones we definitely want to. I feel like there's a lot that we could be doing. So hold on a minute. This fetch guy, shouldn't we see a bunch of allocations in this fetch guy? Array selection from :0. So what we're doing there is we're just resetting it to length 0 so that when people get it back from the object pool, they'll see like a null slice, but in reality, it'll have a bunch of capacity under the hood. That's just the pattern I like to use for these release methods. It feels like mildly safer, maybe. Yeah. Yeah, I think we can definitely save. Oh my God, you guys, this is gonna be so good. We're gonna save so many allocations all at once. I'm actually super, super, super excited about this. Well, so this one's a little bit weird. I will say that this one is a little bit weird because I don't know what the lifetime of these things are. Because this little batch thing, we're allocating it and then we send it somewhere else, and then they sort of take control of the requests, maybe. And you're also doing it. So you started saying pog ironically and you can't stop, and then you also are saying rip unironically, which makes, I think, you also kind of I think we've all gotten taken over by Gen Z slang. Yeah, I think like once we send out these requests, they're sort of like gone to us forever. But I wonder if this says something. The caller retains ownership of all the memory referenced by the batch request. Oh my gosh, this is the dream. So it literally says this. Okay, you guys, we're gonna make some really good things happen here. You've been infected by the Twitch. Pretty cringe. Oh boy. Oh boy. Okay, where were we? Doing something with... We were doing our release, right? Yeah. 5950x. Is it pog? Or is it nog? Remaining batches, we don't allocate. I think the only thing that we allocate is there's this request spans thing, and then there's the there's like a lot going on here. Okay, there's ba.requests, and then there's also scans. So those are the ones that we want to avoid. So I think the way to do that is that over time we'll have to move these into the body of this struct. But I think actually to start, let's not do that. We'll start just with the request span since those are already there and make sure things are working like that first. Build a streaming PC, build 2 for good luck. My friend is building one of those now. And he tried to get his hands on the new AMD GPU that just came out the other day. And apparently those sold out really quickly, just like the new NVIDIA ones. So I guess the point is that I don't think anybody can get a PC right now. It's like impossible. The 6800 XT, I don't really remember the name of it, but presumably, yeah, everything new. It kind of feels like GPUs are the new streetwear. Like people will like get up super early and line up for the drop or whatever. Okay, so here we're gonna say ret is equal to txn kv fetcher, and then we're gonna say return ret nil, but we're gonna say spans are equal to spans, and here we're gonna say spans is equal to ret.spans. And what we're gonna say is if capacity of spans is less than len. Wait, we already have something. Okay, so we'll say, I guess we can just do it like this. If cap ret.spans is less than length of spans, ret.spans is equal to make. So we can just put it up here. Otherwise, we'll say ret.spans is equal to ret.spans sliced to length of spans. And then we say, okay, make a copy of the spans because we update them. Okay, this feels like we could do this more optimally too. We could say if reverse copy ret.spans from spans. Oh wait, if not reverse, my mistake. Otherwise, we're gonna do a loop. For I in range spans, ret.spans of len spans minus I minus 1 is equal to spans of I. Even got the scalpers? Yeah, exactly. What's up, Zero Gross? I'm glad you like the clickety clacks. Okay. So let's I'm not sure if the compiler can notice that this has to be constant, but either way it's kind of gross. So we'll just we'll pull it out and get rid of this. Okay. Okay, so then down here we say spans is equal to ret.spans. Save the, actually we could put this comment up here. Save the memory from the, reuse the slice memory from the pooled object if possible. Don't remember the context, but I was wondering whether copy in a byte for byte for loop would compile to similar identical code. Yeah, there is something. I don't actually know.
The computer's hooked into over 1,000 data banks throughout the world.
I think that you're right. Like the regular for loop will turn into the same thing that a copy will turn into. But I think that the form that we had before probably wouldn't have, because there was like a big fat conditional in the middle of the loop, which made no sense. Like the conditional should have been pulled out. Oh yeah, that's good. That's kind of a good point. A for loop to clear a byte slice get turns into a mem set with null. Okay, so we'll say last span. How about that? Does this make sense? Last span minus n or minus I. So let's see, if we had 5 spans, this would be 4, and we'd be setting. Wait a minute, does this make any sense? We had, yeah, this makes sense. So if we had 5 spans, and we'd be setting the 4th slice, 4th element to the 0th element, the 3rd element to the 1st element, etc. Okay, cool. Very good. So I think that we need to adjust some collars now. This becomes like this. And then this one needs to be adjusted, I think. Okay. Okay. Should we, I feel like we might as well just save the other slice. Well, okay, so let's take a look at what it would take to save this slice memory. I think the truth is that what we should do is just cache this bash request inside of txn kv fetcher instead of making a fresh one every time. I think that's kind of like the strat that should be used here. Because after we send it, I think it's not used again. So, okay, so let's make it happen. Inside of this, responses. Orig span, remaining batches. I think we'll put a
The computer's hooked into over 1,000 data
batch to
banks throughout
send,
the world.
maybe? roachpb.batch request. Batch to send is the batch request that we will reuse over and over to send our requests to the KV layer. We cache this batch because we can reuse the slice memory, or the reuse, how do we say this? The slice of request unions that it contains from request to request. This is possible because the send interface, I guess, the what was the name of this thing? I just want to say, I guess I just want to say this is possible because the sender stack doesn't retain any of the memory in a request, so it's safe to reuse. Basically something like that. Welcome back, Lithium. Hello, Thomas Hermanson. Okay, so when we say var BA, instead of that, we're going to say BA is equal to f dot batch to send. And I think what we'll want to do is probably say MD Layer, thanks for being the command smith, by the way, or I don't know what you should call that, but I appreciate your hard work there. I think what we're going to want to say is BA, basically my mod, right? Yeah, I should definitely mod MD Layer. So Moni, what is up? You're always intrigued with CockroachDB. Very cool. So we're gonna actually say, I guess what we want to say is like BA is equal to roach pb dot batch request, and then we want to say that we just want to really retain the request slice. I think this header doesn't have anything that we want to keep. It's just a bunch of stuff that we're gonna want to actually overwrite quite badly. If we don't overwrite this stuff, we're in bad trouble. So we just want to save the request union. So we'll say request union requests. Wait, what is it called? Ah, come back. Don't do that. Requests. I thought so. Requests is equal to f.batch to send. I mean, I suppose we could actually just cache a request slice instead of a request. That might be a little bit cleaner, right? Requests. Let's do that. So a slice of roachpb.request union. Didomain, I bet. do you there we go. You were beaten to the punch by just be there. Okay, so we'll say request is a cached set, or the I don't know how to say this. Slice of request. Should I just call it like scratch requests? Say reused slice of request union to avoid reallocating a new one on each request. Something like that, right? Whatever. It is all good. So then we get to say our batch is this. And then we slice it to 0. You find yourself missing keys more and more often these days? Oh, like when you're typing stuff? You wish you took typing classes in high school? You would be a big Vim lover instead of VS Code? It's never too late, Simone. I think that I know a lot of people who have gotten better typing. So one thing that I feel like I had to learn because of the split keyboard is that I used to like type, I think it was that like I was typing T with my right hand, but T is like on the wrong side of the keyboard, right? So like I had to fix that when I got the split keyboard because my finger can't like reach all the way over here. And I think there were another couple of like off by ones on the like very right edge of the left half of the keyboard that I was hitting with my right hand. So I think honestly, like you could probably get better at typing by getting a split keyboard because it would force you to like at least fix those problems. But if you have other ones, yeah, I don't know. Going back to laptop doesn't really confuse me, no. It just feels so different. Same with Kinesis, learn to type C with middle instead of
Computers hooked
pointer.
into over
Yeah,
1,000 data banks throughout the world.
Do I look when I type? I sometimes look when I type symbols. Numbers I feel like I have, well, no, I probably do look for numbers, honestly. Sometimes. No, I don't think I do. I don't think I do. I think I look for the symbols and not the numbers. Okay. So when it comes to making these requests, can we do better? The answer is absolutely. Okay, so it's actually not sliced to 0. It's sort of like, okay, requests is equal to f.requests. If cap, we can just go like this. If cap of f.requests is less than len f.spans, f.requests is equal to make. Just copy this. Same thing as what we did before, actually. It's like exactly the same pattern. Else f.requests equal to f.requests sliced to len f.spans. The allocations means memory allocations. Yes, exactly. Okay, can get rid of this. And then that's that. Okay, so what's next? The next thing is that we've got to deal with these. Okay, so what is going on with this? Scans is make struct. Also, don't think you have to use the official way. If it's not split, yeah, that is absolutely true. That is definitely true. Okay, so what the heck is going on with this? What is going on with this? Okay, so here it looks like we do this pattern to pool these, pool the allocations. So it is, somebody already got a little tricky here. Okay. So I think what's going on is that the way that these requests work, the proto buffs for them, is that they have a slice of this thing called request union. Request union includes something called a is request union value, which is an interface. So whatever we put inside of this value has to be a pointer, and it's a pointer to one of these things, request union, whatever. So it looks like if we have a forward scan, for example, we need to definitely allocate one of these, a request union scan, to go inside of that one of. But then what's kind of crazy is that inside of there, then we have another pointer to scan request. I don't know why that's the case. That feels a little bit like protobuf did something weird, honestly. Like it feels like unoptimal code generation by protobuf, doesn't it? I don't know why it's done like that. It feels honestly like kind of weird, doesn't it? Feels like whatever protobuf generator we did, it's kind of doing something goofy. Out of curiosity, what does the protobuf definition look like for this? A request union contains exactly one of the requests. The values added here must match those in response union. So it uses something called a one of. And I guess I don't know how this works exactly. Control D multi-cursor? Well, I can't change these, unfortunately. These are, changing these protobufs would be like, you have to be really, really careful because you can't, yeah, you have to support multiple versions of CockroachDB talking to each other. So these protos are like super scary to modify usually. So let's actually, oops, what did one of protobuf. Does the KV layer run as a separate process? No, it doesn't. Every CockroachDB node is like it's like an everything. It's a SQL, it's a KV, it's both. That is actually going to change if you want it to change. So we're adding this capability and a web server. Yeah, that's definitely true. We're actually going to make it so that you can run KV nodes on their own and SQL nodes on their own, so that you can have sort of a more multi-tenanty kind of thing. But that's kind of work in progress. Terrified Mavis Beacon will come to my house and beat me to death if I don't type correctly. That is a really scary concept. So one of, right? If you have a message with many optional fields and where at most one field will be set at the same time, you can enforce this behavior and save memory. Well, kind of, except We're not really saving any memory. Doesn't seem. They're optional fields except all the fields in a one-up share memory. Oh, you know what I need to be looking though is not the protobuf documentation. It's really the GoGo proto, which I think, I mean, GoGo proto is sort of, uh-oh. I'm nervous that we've had this exact conversation 4 years ago with somebody from my team. Okay, I found that one of is useful to represent some value interface on the Go side. This will generate the following code. Yes, this is exactly what we see. So each of these can be a star to any of these things. And then on the inside, oh, okay. I guess I'm just confused about why. Request union scan. I'm just confused about why this thing has inside of it a pointer again. That just feels wrong. Yes, protobuf is used to communicate with remote nodes, exactly. Yeah, I don't understand why does this generate a pointer? I don't understand. Wait, what? I really don't.
The data bank's too big.
I really don't understand that because
How are you going to do that?
By guessing.
Oh, is it because it's an object? Yeah, but you see how this is these ones are not. I don't get it.
The computer's hooked into over 1,000 data banks throughout the world.
Hey, thanks for the follows, Nylid and C3. Anyway, this is definitely not something that I'm going to be able to change, so I'll just give up thinking about it for now. Point is, we still have to allocate both of these fields. That's what's going on here. That's why we have this sort of double structure. And I guess, can we avoid this? I think to avoid it, see you, Lithium, and see you, Orion. Thanks for stopping by, both of you. I think what we should do is, well, I don't know, is this sketchy? I was gonna say that we could like inspect this request array. So this, okay, basically like if we hit this path, we're going to have like reused a bunch of these batch requests that are inside of this slice. And it's possible that inside of this batch request slice, there will be a bunch of pre-allocated fields, reverse scan request or scan request, depending. So I guess conceivably you could actually check. You could say for each of these things, let's check to see if it's the correct direction of scan and reuse if so, and if not, then you can create a fresh one. But I just don't know if that's like a particularly good idea. It might end up being slower, since what's nice about this is that you get to allocate a big slice of them all in a chunk, so it's very efficient. Okay, see ya, Daitomain. Thanks for stopping by and for all of the suggestions earlier. Thank you for the good luck. You saw the struct field named union and you were afraid that Go had threaded a union keyword? Well, you're in luck. That did not actually happen. You know, I'm just disappointed. I'm disappointed. Why is this thing getting generated in this crazy weird way? Uses unsafe to emulate unions. That'd be sick. You definitely should do that. Yeah, I think this is the issue, right? Hey, Anthony writes code. Thank you so much for the raid. How are you guys doing? Anthony watchers, welcome to Large Data Bank. We are working on reducing allocations in CockroachDB's read path. It's very exciting, and we've had some pretty good success already tonight. Hey, Anthony, how was your coding in the dark experience? I saw that you were doing that with Jason. Jason is actually somebody that I used to work with, so it's pretty funny to see him join the streaming world and you know, do stuff with you guys and everything. So it's pretty cool. I actually wasn't around when you guys were doing it.
Computers
so I
hooked
missed
into
it,
over 1,000 data banks.
It looked like a lot of fun, and I hope to catch the next one if you do another. You need to compile the results. Was there like a winner? Like, and were there judges to try to figure out who had the most accurate? So I think for the people who were not in Anthony's stream, I think the idea was that they tried to make a website that looked like another website without ever getting to see the work in progress of what they were looking like. Is that right, Anthony? It sounds pretty funny. It sounds kind of like those things where you like write a Python program and try to make it do something, but you don't get to run it until it's finished or something like that. You picked via polls. Need a better system for winner next time. Okay, that is truly funny. But that's cool. And again, thank you so much for the raid. So what's kind of funny about these things is that this always seems to happen, is just like if I see something inefficient and I Google for it, it's very often the case that somebody like several years ago from the very same code base that I am opened an issue against a project and they talked about it. That does seem to be happening here. For example, here is your crappy Twitter. Okay, let me check that out. I gotta see it. I mean, I think this is actually pretty good. I'm not gonna lie, I could not have done this. You have the bird, there's another bird, and it says stuff. So I think I applaud you. I think you did a good thing there. Careers link doesn't work, FYI. Hey, Patrick Pie and Zaner4, thank you guys for the follow. I appreciate it. Tsundere Tube Worm, what is up? Welcome.
The computer's hooked into over 1,000 data banks throughout the world.
So this discussion that I'm reading, basically, we used to use a different method in protobuf that wasn't one of, it was like some other union thing. We switched to one of, and the thing that we did to avoid these extra allocations that I'm looking at is exactly what we were looking at in this other code, which is to pool the allocations by making, where is it? This thing. So this is like a weird pattern. We're making like an anonymous struct with two values in it, and we're allocating a whole bunch of them, and then we're embedding one within the other. And the purpose of this is just to make the memory like close by, I guess. I don't know, it's like pretty sketchy. I wanna say that it's quite sketchy, but I suppose it does the trick. It does make me a little bit sad. Like, I don't see an easy way to cache this memory because there are just two types of them, right? There's this reverse and there's this non-reverse case. I guess I could have two fields, or I could say like, was the most recent one a reverse, then I can use this one. If it wasn't reverse, let me use the other one. That also feels sketchy. They ate all your food. Oh, like you cooked food and then they ate it? That is truly the dream. Doesn't it feel good to have somebody eat the code or the not the code, I'm thinking too much about code. It feels good to have somebody eat the food that you made for them. Or ordered for them in this case. Hey, YOLO Schmolo and HP Radio, thank you guys so much for the follow. And C Films, what is up? Okay, so here's one thing that we could do, right? We could say that we're going to inspect the first element of the cached batch requests. So up here, we could say switch f.requests of 0. I guess in this case, right? I guess we could say, okay, so if ba.requests of 0 is equal to nil. So, oh wait, does this even make sense? It's more like, dot value is not nil, right? So by default, this thing is going to be nil. And if we're in this case, we know that we don't have memory to reuse in a sense, or in this case rather, and we'll have to, I guess we have to do it down here, right? So, and I guess we have to do it in both cases too. Okay, so let's just try it out. So if we're in the reverse case, Nightbot is a bit broken. Oh yeah, I think it's because I never added an actual alias for the go command. I meant to steal yours, but then I never got around to remembering what it even was in the first place. So yeah, I think it's actually my bad, not your bad at all. Your favorite cuisine is Vietnamese. You almost got the opportunity to build their national health record system for Vietnam. That's actually pretty cool. Is that what you're talking about? That'd be pretty impressive. So if this thing is not nil, then we're gonna check what type it is. We're gonna say switch ba.requests. Well, I guess actually what we could say is if we could just cast it once. We'll say if ba.requests of 0.value, you can say rev scan, okay, is equal to dot reverse. I guess this is gonna be a request union reverse scan. Roach pb dot. So if this is the case, then I think we can, they made you take shots with them with the chief of police. That is pretty epic. They were too difficult to work with from American company. Yeah, Vietnam is very different. I visited there in January and it was amazing. I really, really liked visiting Vietnam. I spent a bunch of time in Hanoi. It was like super cool place to visit. C-Films, we're not doing any data displaying today. We're mostly doing some like optimization work. Saigon is much more fun. I did, yeah, maybe. I guess I didn't visit there. I would like to go back to check out Saigon, but I didn't do it this time. I really liked how just different Hanoi felt from anything that I had ever experienced. That was my first time to Southeast Asia, and it was definitely extremely foreign to me. And I really quite enjoyed learning about just the city and how it is. Quick opinion for LQ Answer. How would you say is the most efficient way to learn your first programming language? Courses, books, videos, or then projects? Personally, I always recommend that people do projects and then learn as you go, but I know that it can be a little bit hard to get started. I think, yeah, the way that I did it personally was that I was playing around with this old thing called HyperCard. I don't know if you ever played with that. It's like this old Apple programming language kind of thing. and it let you do a little bit of GUI, a little bit of programming, and that's kind of how I got into it. I didn't really set about trying to learn it so much as like kind of just like playing with stuff and hacking on things as things go. I don't know. That probably doesn't make that much sense. Courses and projects at the same time. Short intro and start building a project. I think that makes sense. Hypercard is a name that you haven't heard in some time. What's up, Polymathic Man? I'm not doing too much security. It's mostly like performance. Really, I'm trying to reduce allocations in this read path. I'm basically, okay, so basically here's what I'm doing. I'm staring at this chart, which is a big chart of the stack of the read path of CockroachDB. I'm clicking on boxes that have high numbers, and then I'm looking at why we're allocating so much in those boxes and trying to reduce it. So that's a simple way of saying, yeah, I don't know. That's what I'm kind of trying to mess with. They can, in fact, turn it into a flame graph. All you have to do is click this, and then you have a flame graph. How about that? Pretty crazy. I just find this flame graph really hard to read because I don't know. I just prefer the box and node chart or whatever. I just find it a little bit easier to get my head around. But you know, why MMV? The bottom-up view is nice because it aggregates things. What's a bottom-up view? Are you saying that you can switch it so that this one? I don't know how that would work. Isn't database running on large servers, which means a lot of memory? I think that that's pretty much true. I think that, yes, you want to have a lot of memory in your database servers for sure. That's important. I think that Go is medium beginner friendly. I think it makes you think a little bit too much about memory maybe for a rank beginner. Personally, I always recommend Python to real beginners because it's such a multi-paradigm programming language that you can really try anything in Python and it kind of works out. You don't have to think too much about the details. Personally. Flame graphs can combine function calls so it shows you the total aggregate. That's pretty cool. Yeah, you can do that in this other view as well. If you can make the internal database operations allocate less memory, you can make it faster and reserve more memory for user-facing stuff like caching. Yeah, totally. Last time I checked, it's recommended to have at least 4 gigs to run CockroachDB. Yeah, I think that's probably true. Yay, Python. Patrick Pie. Of course you like Python as a Patrick of the pie. All right, so here's what we're gonna try. We're gonna see if this request, the 0th thing of this request is a reverse scan, and we're trying to do a reverse scan. Then we're gonna assume that all of the requests in this saved slice are reverse scans and we can reuse their memory, which I think is like mostly gonna be safe. I think the trick is that if it's the wrong one, then we have to free everything and start from scratch. And I think that strategy will probably work. I don't know. You run Microsoft SQL and we have beastly 257 gigabyte RAM servers. Wow, that's pretty amazing. Been struggling to find a good tutorial for Python that at the end you can start building projects. I think that I hear that learn Python the hard way is a good introduction. Is that a thing? Learn Python the hard way. What is this? People say that this is pretty good. I don't know though. I'm the wrong person to ask, because I haven't really read any of these. I wish I had a good recommendation, but the truth is that I don't. Automate the boring things. Boring stuff. Cool. Most important thing is to find a community to study with. I would agree with that. I think that's a really good point. You definitely want to have a bunch of people that you can ask questions to and share your knowledge from. I think that's going to make it a lot easier for things to stick. So if we have a reverse scan, what we're gonna do is we're gonna do this loop. I think it's really just the same loop, isn't it? We're gonna say, well, it's not quite the same. We're gonna say for I in range, ba.requests, ba.requests of I dot value, and then we can cast this thing. That's what's so crazy about this. We cast this to roach pb.request union reverse scan. It's like really kind of nasty, but I think that it's fine. And then we get to say scan dot reverse scan dot scan format is equal to batch response. This is gross, dude. I don't know. I think this is just what we have to do. If we actually want to save this memory, which we definitely do, this is the way to do it. F.spans of I. It would be nice to run CockroachDB with low amount of memory like Postgres. Then you could run it in your personal projects that run on a $5 machine. I mean, I think that you might be able to do that, JustB. I think it just might also have issues. I think it's just, the recommendations are really more about like what we've tested. And we typically don't test CockroachDB on really memory constrained environments. So we can't really recommend it for production deployments. It doesn't mean it won't work. It just means that we haven't really tested it. But I agree with you, MDLayer, that it's not really the right use case for small memory constrained environments for the most part. I think you have to really think about, I mean, you're gonna get the wrong answer from me. I'm a CockroachDB shill. I think you should use CockroachDB for everything. But I think at the same time, you also really need to think about like, what is the purpose of the project? Like what do you need out of the technology that you're gonna be building your project with? And if it's something that's really low throughput, low memory, constrained environment, low concurrency, SQLite, good choice, Postgres, good choice. Really just depends. CockroachDB is better for applications that need to scale horizontally. I think you can't scale SQLite horizontally because you can't have a networked SQLite really. I think there's like some projects that try, but they have like major issues. Postgres you can scale horizontally using like asynchronous replication and stuff, but that has serious problems too because it doesn't let you have a consistent database. It lets you have things, you know, I don't know if you've ever seen where it's like, oh man, my like read replicas are like out of date or something like that, and so my application is inconsistent. That's like a big problem with sort of the naive Postgres replication. And so Cockroach is good if you want to have just a regular old SQL database where everything's consistent, everything's serializable, but you can also scale it horizontally, and you can scale it to multiple regions too. Dr. Beardsley, what is up? I haven't seen you in the stream in a little while. I hope you're doing grand. I think performance benchmarks on single node may not really be as helpful as you think though, Lithium, because again, it's really all, we won't win. If you're hoping that CockroachDB will win against Postgres, for example, on a single node benchmark, you're going to be really disappointed because we just don't. The reason is that, well, the reason is kind of complicated, but the point is that if you really want something that can scale horizontally, you shouldn't be as concerned with that single node performance. What you really want to do is a big test like TPCC, or I'm just smiling because I know Dr. Beardsley is thinking about these things too, but TPCC or a key value benchmark or a YCSB or something like that, that sort of lets you do a horizontally scalable test that sort of is more realistic for something like a website that needs to scale a lot. SQLite and Postgres won't scale if your project gets popular, CRDB will. It's all trade-offs, no correct answer. These things are all pretty true, I would say. You have to think. When it comes to choosing a database and choosing technology for a project, you really do have to think. Wouldn't use Mongo on a single node. FaunaDB is a really interesting project with some different trade-offs than Cockroach has. Healthcare are weird queries. You use temp tables and stored procedures. Yeah, I mean, for that, it's sometimes you are thinking more about like an OLAP database that is better for like Snowflake, for example, is something that is well suited for OLAP-y kind of queries, which is just judging by my guess of what you're doing. You probably want something that's closer to that than something than Cockroach. Cockroach is really what we call OLTP, which is about transaction processing. More about that than the analytical big queries, huge aggregations, huge scans, and stuff like that. Lancet and mutilate. I haven't heard of those. I should probably write that down. That sounds interesting. Lancet load generator. Mongo is fun to use. It's not that bad. Okay. I'm just, yeah. You know, I think what we could do is we could say scan dot reverse scan dot. You know what we could actually probably do is just set all this stuff up ahead of time. So we're going to say batch. And then we can actually pull this thing out, right? Document model doesn't apply to majority of data. Relational versus joinless. Okay, so we're gonna stick this here. And then over here, we're gonna say request for
The
then we're
databank's
gonna
too
say
big.
scan dot first
I have to
scan
narrow
dot.
down the search
How are you going to do that?
by guessing.
Hey, Node Ned IJ5, thank you for the follow, and Muscarian, thank you for the follow as well. Okay, so what else do we have to set on this thing, or is that it? Scan format, key locking. Just these three things. Okay. So then at this point, I think that we're done, right? Does this make sense? I feel like this is just going to be so confusing. I don't know. It's just really quite difficult to reuse all this memory in the right way. Yo, what is up, Availabona? We are working on reducing some allocations in CockroachDB's read path. You bought Golang to support the Go community? Do you think buying Golang actually supports the Go community? I think what you're supporting is JetBrains. Yeah, exactly. But I like where your head is at. I think that supporting JetBrains is a fine thing to do too. But I don't think it necessarily supports the Go community per se. So I think what we would have to do here So it's like, let's write a comment. Like if we see that the first request in our cached request slice is a reverse scan, we can assume that the rest of the non-nil requests, and I think that this non-nil thing is actually pretty key. Or is it? I'm just a bit confused. Let's just keep writing this and maybe we'll figure out what's wrong with this over time. We can assume that the rest of the non-nil requests in the... I mean, I suppose the other thing that we could do, instead of trying to like reuse the, like cast these things, what we could do is actually save this memory and then still do this sort of like pointer swizzling thing down here later down. Maybe that would be simpler. I think one potential issue is that like, could this number be really high? Like, could we be instantiating these things with like a huge number of spans that we wouldn't want to really retain? I think the answer is like kind of yes, but maybe it's like kind of fine. I don't know. I don't know, guys. This is a little tricky for sure. I don't think that this is gonna work. I think that I should try to do this other thing. So here's what we're gonna do instead. I think what we're gonna do is say that we're gonna make another little scratch struct. And I think what we should probably do, whoops, other way around, scratch. I think what we should probably do is stick these things, this requests thing here as well, just so that you can kind of tell which of this is memory that's just being reused for the purposes of reducing allocations versus things that are like actually important to keep around for like the state of the object. So we're gonna have a request and we're gonna have a scans. And the scans is gonna be a slice of, oh yeah, it's kind of this weird anonymous struct. So we should actually make this into a non-anonymous struct probably. So we'll grab this. So we're gonna have a, so sort of type rev scan alloc struct, grab these things. And we're gonna have a scan alloc. And this is gonna be a scan request, and this is gonna be a normal scan. And then up here, we're gonna have scans, scan alloc, and then a rev scan alloc, rev scan alloc. Oh, wait, rev scans rather. Okay, so at this point, oh, this is now f.scratch.requests. Okay, so then what we get to do, we can forget all of this crap, which is like extremely confusing and bad. And then we get to say scans is equal to f.scratch.revScans. Now, if len scans is less than f.spans, it's actually cap. Then scans, or then we say let's actually just stop assigning this temporary variable. I think we'll say f.scratch.revScans is less than f.spans. Then f.scratch.revSpans is equal to make. Then here we're gonna have a slice of revscan alloc. Is that what I called it?
Databanks.
What happened to what? Did I like delete those? So confused. So confused. What? Hold on. Did I like put it in a different file? Is that what happened? I guess I just deleted it somehow. That is deeply confusing. Okay, doesn't matter. We can easily recreate it. Rev scan alloc. How did that happen? I'm like so confused right now. Rev scan alloc struct. Okay, back to good. So here we're gonna say make rev scan alloc when f.spans. Otherwise, I wish that this was like there was an idiomatic way to do this thing, because I've done this little if then thing with capacity and make and otherwise slice so many times at this point that I'm like, why isn't there like an easy, obvious way to make this happen? Okay, so I guess probably then you would like encourage people to do this a lot, which you like probably don't need to most of the time. Maybe that's the issue. So then we say f.scratch.revscans. Okay, then I think we should alias. So at this point we say scans is equal to f.scratch.revscans. Okay, cool. Then we're gonna do the same thing down here for the non-reverse scans. Okay. Okay. I think that this should be good then. Let's go quickly back to our thing here. So this is what we were messing with. We also messed with this one, I thought. Oh yeah, there's one more thing that we have to do, which is that we've got to save our scratch space. I guess here we have to, yeah, that's a little weird. Whatever. This one is quests. Okay. Okay, I think we should maybe be good. Maybe be good. Maybe. All of our makes are nicely guarded behind these capacity checkers. Close returns no error. I guess not. I don't think that there's anything that could go wrong for close, at least in this particular case, so guess not. And let's just quickly check. We are actually using this when we make a fresh one, right? I think we are. We are not. We have to say scratch ret.scratch. I wonder, should spans go inside of scratch? What is this? No, I don't think it should. Spans is not scratch at all. Spans and scratch space from our pooled object. Okay, let us make a commit. Do we have anything here? Git commit. We're gonna say row reduce allocate. It's actually, I think it's basically exactly the same as the last one, right? Reduce allocations in KV fetcher constructor. Well, let's make a new commit, whatever. Row reduce sort of like save some slice memory. I guess we could just say pool allocations of TXN KV fetchers. The TXN KV fetcher is an object that's created once per, created at least once per SQL query. It contains a lot of slice memory that has to be reallocated on every, that had to be reallocated on every call to every new on construction. A good opportunity for an object pool. This commit adds an object pool for the TXN KV fetcher that keeps around a bunch of this slice memory. So that, yeah, I mean, that's the end of, it's the end of the story. You wanted to get an article about shared memory in GopherCon? I wouldn't think of it that way. GopherCon's speaking slots are extremely competitive. Applied 3 times and only been accepted once. Dang. Shared memory between Go routines and separate processes. That is intense. Okay, so let us fetch. We'll rebase. We'll make build. Let's see if things work. Implementing a network protocol in Go. I don't know if I've actually seen or read this. From GopherCon 2018. Bam. Crisp looking slides. Crisp looking talk. Neighbor discovery protocol. Oh my goodness gracious. This is some serious business. I would, at this point, I would not be raising my hand. Okay, so let's run our server. Run our workload. And let's retake a heap profile and see what we get. Well, this is suspicious. I think that there's probably something that's going wrong with our object pooling, potentially, because I think that these numbers should be a lot lower if we did things right. Right? Let's actually we'll take one more. Yeah, definitely something didn't go quite right with the object pooling. That's fine. We can fix that. Let's actually go ahead and take a look at this guy to make sure to see what's up in where we actually end up using the This is interesting. I would say that this is interesting, and I think that potentially gonna have this on YouTube. I try to upload these things to YouTube. I have like a really badly long backlog. I usually like export all the streams to YouTube, but then I haven't like publicified them because it takes a little bit of work to edit them. But actually, if you're asking, I'm happy to do it. I didn't know that actually people would be interested in watching them, to be honest. So I just like archive them and then don't make them public. But I appreciate the push. Okay, so we're missing this is one problem. This needs to be f.spans of 0. Oops, like this. It's your first time here and you remember seeing on the Gopher. Oh, thanks. Oh, that's awesome. That was really fun, that lightning talk. I had a lot of fun doing that. You didn't upload your last one because it felt it wasn't super good, but you tried to otherwise? No, Dr. Beardsley, there's this really awesome thing that you can do where you just click export. It's like super easy. So if you go to your videos, then there's a little like 3 button thing, and then there's like an export option. Oh yeah, you sort of like are more of a yeah, do everything yourself by saving it locally. I think that would probably look better because I think Twitch does like down encode it or something, but it is what it is. I do stream to Twitch with OBS, yes. FFmpeg. OBS is a really, really good piece of software. If you guys want to learn how to use OBS, I wrote an article about how I use it to stream to Twitch. That's in my bio. So check that out if you're interested. Okay, so this explains why my spans slice is not getting reused. But it doesn't explain the other stuff not getting reused, which I'm a little bit more concerned about. The real question is whether I'm a little bit nervous that this is never getting called, which could be like a serious problem just in general. But in any case, now that this is fixed, let's just quickly re-upload that one change just to check whether that makes anything better. Oh, the problem was that I reset to the wrong branch, I think. Wait, is that true? It is not true. Okay, git reset hard mine sender func allocs. Make build. I think that the computer architecture course that I took in college was awesome. That was one of my favorite classes. Learning about memory architecture is really important to understand how computers work, I think. It is true that you're probably right that you don't strictly need it. But that being said, I think it's really, really, really good to take because I just think that there's this word called mechanical sympathy that people like to throw around, which I like quite a bit. Mechanical sympathy is the idea of trying to have sympathy for the things that you're forcing the computer to do. So if you're writing code that's really cache unconscious, and you're constantly forcing the cache to thrash back and forth, it's helpful to know that you're doing that, having sympathy for the computer that's having to throw the cache memory back and forth from RAM or something like that. So you can sort of understand like, this is probably why it's running slow. Something like that. I don't know. I think it was one of my favorite courses though. So that's just my 2 cents. I wish CS was top bottoms up. How does the machine work and how can we manipulate it? But I agree that it does depend on what kind of software you want to create. Oh wait, you're saying Dr. Beardsley says it doesn't matter what kind of software you want to create. I guess I was thinking that depending on your goals. I don't know. Discovered mechanical sympathy from Martin Thompson's talks in Java. I don't know if I've seen those ones, but that sounds cool. I think I discovered it when I think there's somebody's blog that's called Mechanical Sympathy Blog, and that's I was linked to this blog when I was being taught about coordinated omission, which is a problem that happens when you're making load generators. That somebody there's some code that like is around to sort of fix your histograms to account for coordinated omission, and I think the name of the blog that had this article was called Mechanical Sympathy. So I was like, what the heck is that? And I looked it up and I found out. If you write Prolog for a living, you probably don't care about memory and register renaming. Gil Tene's blog. Yeah, exactly. That's exactly right, Just B. Okay, where are we at? So let's take a look at our make function. Gil Tene from Azul did a lot of stuff on coordinated omission. Yeah, exactly. So yeah, I really feel like we're not actually returning these objects to the pool, which could be really problematic. Out of frustration that people weren't benchmarking the JVM correctly. So Somoni, I think the performance test that I'm running right now does not take care of coordinated omission, because it's just running a benchmark that is made so that as soon as a request finishes, it starts up a new one immediately, which is sort of like the point that coordinated omission has a problem with. If you were having a real web server that you were trying to benchmark, or you're trying to simulate real load on a web server, requests wouldn't wait for each other to finish. They would just keep piling up. And so that's the sort of thing that you need to watch out for when you write a load generator that just starts the next request after the last one is finished. It's not going to be that realistic. You need to be making more threads if things aren't keeping up. But I was going to say, there is the load generators that we use in general do have facilities for this. And the way that it typically works, is that you kind of need to have like a sleep phase of each request and have like way more concurrency. This sort of is more close to reality. You can have a request that always sleeps 10 seconds and then does a request and then goes back to sleep. And then you can increase the concurrency quite a bit more using that strategy. And it's going to just act a little bit more realistic. Coordinated omission appears when measuring latency, not throughput. That's true. I guess you're right that it's sort of like it's just one facet of the problem with a benchmark that doesn't sort of behave realistically. That's a good point. Somebody outside, they decided that you got to go fast. Did you guys hear that motorcycle thing or whatever? Okay, so I'm a little concerned here. We have to figure out why these things aren't getting returned to their object pool. That's the next problem. The more throughput, the worse your latency? Well, it kind of depends. But yeah, it is related. I mean, it depends on the concurrency. I think that there's like formulas for this stuff, and that I don't know them off the top of my head. But there's ways to think about this stuff in a really formal way that are useful. So we got to get to the bottom of this now. We have to figure out why this thing is not getting returned to the pool. And it's a little bit suspicious, I have to say. So I think what we're going to do here is do a little bit of the old print line debugging. Returning a myself to the pool. Not using delve, not pog. I almost used delve earlier on the stream to debug a unit test, which is a great use case for delve. I feel like we definitely call close here. So I'm actually really confused right now. The opposite of pog has to be like, it's like one of those, I don't know. M. Dembski tried to use delve the other day and was super lost. Oh man, I wish I was there. Gop. Kavya made some great talks about this on YouTube. Favorites dumbed down explanation. I should check that out. It'd probably help me. Okay, let's see. Well, I don't see anything getting printed. Oh, did I not, I didn't fetch. I didn't do anything right. Need to fetch, need to reset, need to rebuild. There we go. Some Go packages being compiled now.
And I start sweating, and I start...
Okay. Let's try this again. Okay, so we're getting some, I'm guessing we're gonna get, so we don't get anything. Oh wow, this is really, I'm actually like a little bit concerned. I'm actually like very concerned because this really needs to be, this like needs to be called. I'm like a little bit actually confused why this could not be getting called. Oh, is the issue that this thing uses a lower level API? I don't think it does. Right? Like, doesn't this, what is this? This is calling this, make KV batch fetcher, and this is the thing that is returning this. Okay, so, I don't know, dude. This is, it's not looking good. It's not looking particularly happy. It's looking extremely suspicious. It's looking extremely suspicious, I have to say. And I don't know quite what to think. I don't know quite what to think. How could this not being, what the heck? I mean, I guess the solution is really that like we're supposed to propagate the close here or whatever, but that's not exactly good, right? It's like really not very good. And I just don't actually understand. Oh, we pass a nil memory monitor here because the C fetcher does its own accounting. Okay, explain that. Please explain yourself. How could that be the case that it does its own, quote unquote, its own memory monitoring? Like, what does that even mean? What does that even mean? How could that be possible? Okay, so you guys, what's happening here is I've told you many times on this stream about the fact that we have to pay attention to the amount of memory that we're allocating for like, not the like setup stuff, but like the real data, right? Like the bytes we're pulling from disk. We've got to be tracking those so that we can know how much memory we can do so we can spill to disk if we need to, right? The database has to manage its own disk spilling. Fun stuff, really fun stuff. So the way that we do that is we keep these memory accounts around and we like mess with them and poke at them and stuff like that. Okay, what the heck? This is actually wild. It sort of seems like, oh no, never mind. So there's actually no point for us to keep this anymore, it seems like, because we don't use it as a field. We could kind of just go like this, right? That's one thing. I'm actually like, yeah, I don't know. So I see. I guess we have some conditional logic that says if we are doing monitoring, then you can do some stuff, but we don't monitor in these other cases. So the reason for that is that presumably in this path, we are paying attention and we have our own memory monitoring that is used to pay attention to the maximum that we could possibly get back from the scan. Is that how it works? Why is it expensive to monitor? It's not expensive to monitor. So the reason, yeah, the reason is basically that there's two code paths that use this stuff here, this TXN KV fetchers used in two different contexts. One is in the like, it's kind of just like a legacy code issue. We have two engines in the database. One is what we call the vectorized engine, which is like the new hotness that's more efficient, faster, more memory efficient, kind of just like better in all sorts of different ways. And it has like more advanced memory monitoring capabilities because of the way that it lays out memory. It's sort of a column oriented memory structure. So it's easy to account for how much memory is used by each column basically. Whereas the row at a time one was, it's like quite difficult to pay attention to all the memory that's used in the row at a time execution engine. So that one has got to use the memory monitoring in this thing. I don't know. It's like, to be honest, Simone, it's a bit of a mess. It's a bit of a mess. But the point is that in the row at a time engine, since we don't do our own memory accounting there, we have to delegate it to this guy. And it's like a little bit of it's like a safeguard, this kind of memory accounting, as opposed to the vectorized stuff, which is like more accurate. It's basically like, okay, so in the row at a time engine, we like account for memory that's buffered. So if you're like doing a sort operation, for example, in the row at a time engine, we do account for all of that memory in the sort, like as you're accumulating a huge buffer to sort. We don't account for like the sort of transient memory. So if you imagine like you're doing this big query, you're streaming rows through the query. Maybe you have like, 128 rows streaming through the system all at once. If those 128 rows were using like a kilobyte each, we wouldn't be accounting for that 128 kilobytes of streamed memory. And so as a result, we added some like sort of sketchy accounting at this layer to try to hopefully deal with that and to avoid added memory issues due to wide rows. This is really all about like wide row protection actually. In the vectorized engine, on the other hand, since we do, yeah, exactly. It is all contiguous memory. So since we use contiguous memory, we can account for all of that like sort of quote unquote streaming or transient memory very easily. So we don't have to ask for the KV fetcher to do it for us. That's like the long and short of it. Yeah, it's a little bit messy, to be honest. A little bit messy. Daniel, this is Goland. So the yes. Okay, so what is going on? Oh yeah. Okay, I remember now. So right, this is actually kind of cool. All your atomics and lock-free code. Actually, so this part of the code doesn't actually need a huge amount of, or really any concurrency control, because each SQL query is sort of like a more or less single-threaded operation that has all of its memory scoped to itself. So all of the like fancy lock-free stuff, concurrency, that all happens actually lower down at the KV layer. Most of it. There's some at the very top where we do the like, you know, connection stuff where we're, you know, taking new connections from SQL land. Sorry, this is like bad. There's concurrent code at the very top where we switch connections from being just network connections into like things that the database understands as sessions. And then there's like a bunch of single-threaded code. And then towards the bottom, it turns into multi-threaded code again once we're like actually trying to serve the like underlying KV requests. If you recall, CockroachDB is sort of like a half SQL, half KV system. It's SQL at the top and KV at the bottom. I don't know if that was comprehensible. But it's kind of nice. I mean, one nice thing is that, you know, the SQL code, a lot of it is single-threaded. There's like a little bit more concurrency than I described because of the fact that the SQL system is also distributed itself, meaning that you can make a big complicated join and aggregation where we push down, you know, the filters all the way down next to the actual processor that's reading the disk on the node that has the data, right? So like in certain circumstances, we do a much more complicated distributed flow. And in those cases, we do have a bunch of concurrency in the SQL side, but it's also like sort of at the edges in a sense. Like each SQL operator, all of these like fetchers and the joiners and the aggregators, for the most part, all of those things are single-threaded. And we try to keep the concurrency sort of at the edges and at the boundaries of these things to make it simpler. What in the heck is that? Squashed emoji? Okay, I think this is signal for me to try to figure something out. If things are atomic, it has to be single-threaded somewhere. Wasting large data banknotes. Yeah, these things are like a dime a dozen. They're worth nothing. It's hyperinflation, large data banknotes. Does this mean I have to propagate context into all of my release methods? I really don't want to do that. I'm just going to pass context.background since I know that in this case I don't need to. We can pass. Actually, I think I can actually just pass nil. Is that allowed? I think so. Pass nil here because the fetcher stack only needs a context to the context virus. It does spread everywhere, but it's also useful. Like once you've spread it out, it like is fine. It only needs a context to close its memory counting. Oh my god, is this real-time Dominic static checking? That is a got him. Okay, fair enough. Static check bot. Dude, imagine if you had a code review bot that watched a Twitch coding stream and did real-time static check. That would be like the most out of control thing I've ever seen. Pass. Only needs a context to close its memory accounting, which is disabled because the vectorized engine does its own scan accounting. If it would look vaguely human too. Okay, and so here's the truth, you guys. Like, I feel like I really wish that I could pool the fetcher along with the C fetcher, right? And then likewise, how this is actually getting, well, no, this is the end of the chain, isn't it? But yeah, I feel like this fetcher should be stored inside of this thing rather than, because then we would save yet another allocation, right? Instead of, we could store this as a non-pointer type is my point. But I think that this is going to have to happen at another time. Plot twist, static check just sends me emails and I look over the code in real time. TFW, I'm too dumb for Go context. I think that you'd be surprised. I think that you can figure them out. Yeah. I think where they get kind of confusing is with cancellation and the channels that you use for the cancellation and stuff. Don't shove values in them. Hey, do you want to see something funny, MD layer? Oh, wait. It's a pretty big oof, right? Pretty big oof. So Moni, no, I'm not trying to move all code from a pointer type. It's just every time that you have an object that you have to allocate in a stack of objects that you've already allocated higher up, it's just sad, and it makes me feel sad. So you can avoid doing that if you're tricky about it. Yeah, so this is pretty sad. So the reason we use this, one big reason is this stack here, log tags out with tags. What log tags is, it's actually a pretty cool package. And it actually is a package that you can use outside of Cockroach, but basically like you see in these log lines, you can see how there's this N1 thing in a little square bracket. The way that this works is that stacks can annotate themselves with like little bits of information. N1 means node 1. And if we were writing logs for stuff that was for a particular range or for a particular replica or a particular store, you can add these tags. And then everybody down below, when they log stuff, it's going to include that information in this little bracket thing automatically, which is extremely handy for debugging when things get complicated, and things often do get complicated. So I think it's like a pretty good use case. It's just that the stupid context package is just so allocation heavy. Now that we have Go 1.15 though, we don't have to, we can actually make a custom context implementation. We didn't used to be able to do that because of the context cancellation path, which checked a bunch of like Go specific things. And if you tried to implement your own context, things would get like bad or break or something like that. But they fixed that. So I think what we wanted to do is like put a bunch of these fields that we're constantly using over and over again, like the log tags field and the like SQL statement field, which is I think one of the other big allocations here, and stick that into like a struct. Oh wait, span. Yeah, it also gets confusing with the old distributed tracing stuff. I don't know. I mean, it's complicated, I guess. We try to do a lot, and it sort of works, but also is expensive, I guess, is sort of the moral of the story. Anyway, so I think like this is sort of like a to-do, Jordan. This should really be stored as a struct type as a non-pointer, since the cfetcher itself is pooled. Ideally, we'd have a function that initializes this fetcher and doesn't allocate one. So all of the memory could be happily pooled together. Next time one of your marketing people email me, I'll tell you an engineer said it sort of works TM. I didn't mean the database. I just meant the logging strategy. God. Okay, so let's add this. It is funny. It is truly funny. I mean, software is always scary. When you actually like work on it, I don't know. Does any software actually work, you guys? That's a question that I have. It's like very unclear to me. All software is scarier than you think. There are always shortcomings and sharp edges. Maweef says absolutely not. I think software, like, it can work for a time, but it always rots. It's always got issues somewhere. If you're willing to look deeply enough, you will find problems. SQLite does work. I think SQLite is a pretty good piece of software. But I will say, so you guys know about SQL Lancer, which is this really awesome test suite that was developed recently for SQL systems. SQLite found, SQL Lancer found a ton of bugs in SQLite. I mean, it's like once you write this tool, SQL Lancer, SQLite. Wait a minute. SQL Lancer paper. So this guy, Manuel Rigger, is really interesting, smart person. We worked with him a bunch on Cockroach, actually. We were lucky enough that he was interested in testing Cockroach with his software. And I think, oh wait, maybe not this paper. There's another paper, maybe, that had testing on Cockroach. Okay, so in total, we found 99 bugs, namely 65 bugs in SQLite, 25 bugs in MySQL, and 9 in Postgres, demonstrating that this approach is highly effective in general. This is like really interesting stuff that you should read about if you're particularly interested in it. Anyway, okay, so let's try this one more time. I think this should hopefully fix my pooling issue. So we didn't remove the print, did we? So that's going to be problematic. Well, let's just check to make sure that it prints a lot. Okay, so we get a crash. That's better than nothing. I guess I have to scroll up using screen. Okay, so KV Fetcher 131. SQLite's dynamic data type things confuse me. This column is an int, but it's perfectly happy to let you put a string into that column. That is a little bit weird. I would agree with that. So this thing is nil? Wait, what? Oh, this is nil. Oh, it's because I just did this in the wrong order. Oops, that's an easy mistake to make. Hello. Mm-hmm. Yes. This is Becca.
Hello.
How is the pottery?
I'll show you and all your fans.
Fans? You're about to see some amazing pottery, I think. Wow, you're getting a lot of hellos.
Hello, hello, hello. Wait, who wants to see some bad pottery? Show it. Come on.
I'm not sure if it wants to. I think it's pretty good. I like the divide. You got the glazed top and the unglazed bottom. I think this is actually a big improvement. I like the handle. Can I hold it?
Thank you. Okay.
Very ergonomic. Yes.
Sorry to disrupt the content.
No, not at all.
The other ones are gonna take a minute. Oh gosh. Too much pressure.
Yeah, the pressure is really on when you're trying to remove pottery from a bag.
I just want to show my pottery. Ta-da!
Ooh, this is nice. This is really nice.
Tiny
I am into this one.
bowl. Maybe a cereal bowl.
Could be.
Could be better.
But I think it's quite good.
Could be better, but it's an improvement.
Here's what people say. They say, I hear your brownies are great. Mugs are the best. Is that an airplane? It's some nice pottery. Looks solid compared to software. Unlike most software, it actually works. I want to go do pottery with my kids one day.
They should do pottery because pottery is a good pandemic activity.
It is a good pandemic activity.
All right, I'm just gonna put them here. Thanks for tuning in. Goodbye.
Okay, bye-bye. Good stuff. I think this means I should probably sign off soon. I'm hoping to fix this little last thing and then test it and then let you guys go into the ether, into the night. Okay. Fetch. Reset. Make build. It is useful if you have streaming as a hobby. It's useful if your significant other also has another hobby that they do it about the same time as your hobby. That way you don't drive them too crazy. I think streaming is a pretty easy way to drive the person that you live with absolutely crazy. Okay, try this out. Of course, I didn't delete the stupid print again, so that's dumb. Okay, great. We're getting a lot of prints. We're doing good. We're doing good. Let's get rid of the print, and then I think we should be good to go. It's called SQL Lancer. SQL Lancer. It's more of a research project than, I don't know if it has executable code right now. It's more of a research project, I think, but I'm not positive. But Manuel, the guy who made it, or I think he led it, he's a really nice person, and I bet he would probably, if you tweeted at him, he might give you the software or something, I don't know. Is there a good HTTP perf toolkit in Go you would recommend with high throughput and decent coordinated omission support? Unfortunately, I have no idea, Somoni. That's a good question, though. Vegeta? Is that a real name? That's pretty cool. It's a good name for a piece of software. Okay. All right, so let's collect another heap profile and check out what's what with it. So this is actually pretty good. I think this TXN KV fetcher used to have a bunch. It was like 2 or 3%, and now we're at 0.4%. So let's look at what's left on it. Whoops, it's the wrong thing to click.
The data bank's too big. I have to narrow down the search.
How are you going to do that?
By guessing.
Adam Zhang, thank you for the follow. So there's still something, there's still a little bit more to do. This request spans for some reason is not getting, why is that? Did I just, request spans, there I set it. And then do I not do it in the constructor? It's probably that. I'm not setting it in the constructor. That is indeed the issue. Request spans. Now our request spans, are these things that we should be setting in the Scratch land, I think? I don't think so. Oh, but you know what's interesting is actually this is not going to work anyway because we do this stupid pattern where we keep slicing it down. So we're going to have to do more work to fix this one, but I don't think it's going to happen now. I think that it's time for me to say goodnight. Whoops. That was absolutely the wrong button to press. But anyway, you guys, just wanted to say thank you so much for hanging out with me today on the stream for so long. I feel like this was a long stream with a lot of good interaction. Chat, I appreciate all of you. Thank you so much for sticking around. And I hope to see you again back on the stream soon. So I think what we're gonna do now is probably raid somebody. So let's pick somebody to raid. And I will try to put this
Computers
on
hooked into over 1,000 data banks throughout the world.
YouTube's, since at least one person's interested, which is pretty cool. Hey, Scopio developer, thank you for the follow, by the way. I will try to put this on YouTube. I do stream every Friday. Sometimes I stream on the weekend. I haven't in a little while, but I try to often if I can, if I feel like it. And you know what we should do? We haven't rated this person in a while, but why don't we just go ahead and do it anyway, just for the fun of it. You just got here. Sorry, dude. Kiva Show, please come back another time. We're gonna raid one of the most popular dynamic streamers on the coding and technology world. You all probably know and love this person already. Hopefully you love him. Definitely you know him. We're gonna raid the Primogen. Follow you to get the notification. Appreciate it. I will not raid that guy again. I think last time I did it, it was a little awkward. Kaiza speedrun. I took a break. Maybe we'll be back later. Anyway, you guys enjoy. Say hello. See you another time. Bye bye.
It's a full-on one. No, I'm not gonna do that. No. Large data bank. Rating with a party of 27. My goodness, my gracious. The second rate of the Nate. Feeling rated out of my mind. Welcome, 27 viewers. Girthy data banks. Those are some girthy data banks. Kavosho. I feel like you're already followed. This is a that's a misclick. You're in the Discord. How did that even happen? Hello, how you doing, buddy? I've heard about a coffee pot. I just didn't know about the protocol. That's the coffee pot. Because let's see, get in the coconut oiled out of your mind. People get on in. Eliezer, welcome. No, I got one more month of USD.